Hello and good afternoon, everyone, and a very good afternoon to my dear lovely students. In the previous session, we covered all the named reactions of organic chemistry, but knowing a reaction is not enough for NEET. The real question is, how does NTA actually ask questions from these reactions? But before we move ahead, let me know in the chats that if I am perfectly audible and visible to each one of you. Let me know in the chats if I am perfectly audible and visible to each one of you. Let me know in the chats quick. Let me know in the chats quick. Let me know in the chats quickly. Let me know in the chats quickly. Okay, all right. So today we are going to solve more than 100 NEET PYQ based questions from most repeated organic reactions. So keep your notebook ready and try every question before looking at the answer. I would want you all guys to be with me till end of the session, and I also would want you guys to mark the attendance by smashing the like button. So without wasting much more time, let's get going. Let's get started, my dear lovely students. So are you ready for today's session? Are you ready for today's session? Do let me know in the chats. Do let me know in the chats. Are you guys ready for today's session? Because today's session is going to be very much important. Session will be of 3 to 4 hours maximum. It will be 3 to 4 hours maximum. So are you guys ready? Are you guys ready? Come on, my dear lovely students. Okay. So without wasting time, let's get started. Let's get started. Without wasting time, let's get started. Have a look. So, but before we start today's session, let me tell you that I will be sharing the handwritten PDF of today's session on my new Telegram channel. If you have not joined yet, join it quickly. Join it quickly. So this is the Telegram channel which you have to join. So I will be sharing notes of today's session, or I mean to say PDF of today's session on this channel, which is t.me KK Sir Chemistry class. Now, my dear lovely students, this is our first question. Our first question is on screen. Now, what is question number 1? Question number 1 says, is this slide visible to you? Yes, this is visible. Now, question says that CH3CH2CONA gives CH3CH3 plus Na2CO3 in presence of or on reacting with NaOH plus. You have to find out, you have to tell me, what is this? What is this? We know this reaction is like this actually. Reaction is actually CH3CH2COONA, and you have to tell me if this on treatment with NaOH plus something, you have to tell me what is this, and on heating results in the formation of CH3CH3. First of all, you should know which type of reaction is this. Tell me, which type of reaction is this? It is simply decarboxylation. This is simply decarboxylation of what we call carboxylic acid by using soda lime. But what is soda lime? Soda lime means NaOH and CaO in the ratio of 3:1. That means this is actually CaO. That means our option D is the correct answer. I hope everyone knows the answer of this question. Exactly, exactly, exactly. I would want you guys to answer me each and every one question. To answer me every question in the chats. Now, after this, our question number second is alkane that gives only one monochloro product on chlorination with chlorine in presence of diffuse sunlight is. You should know this. You should know this. That whenever your alkane undergoes halogenation, say for example chlorination, in presence of light or heat, it can form monochloro derivative. Now the question is, how many monochloro derivatives will be obtained from an alkane? For that, you have to check different types of hydrogens. That means if alkane is having only one type of hydrogen, you will get only one monochloro derivative. If alkane is having two different types of hydrogens, you will get two different types of, monochloro derivatives. That means which type of reaction is this? This is simply chlorination taking place in presence of light or in presence of heat. That means this is simply halogenation of alkane. And halogenation of alkane is simply free radical substitution reaction. Now, you have to tell me which alkane among these will give only what we call only one monochloro derivative or monochloro product. You have to tell me which among these will give only one. First option is isopentane. Isopentane is this one. This is isopentane. Now, 2,2-dimethyl-butane is this one. 2,2-dimethyl-butane is this one. Then neopentane is this one. Neopentane is this one. Finally, N-pentane is this one. What we have to check is, number of different types of hydrogens. These are having 1, 2, 3 and 4. So this is having 4 different types of hydrogens. That means upon chlorination, it will form 4 monochloro derivatives. But it can form 1, 2 and 3 monochloro derivatives because it's having 3 different types of hydrogens. This is having only one type of hydrogen, so it will give only 1 monochloro derivative. It is having 1, 2 and 3 different types of hydrogen, so it will give 3. So question is, only one monochloro product among these will give. It will be given by this one, what we call neopentane. That is why our option number C is the correct answer. I hope this one is clear to each and every one. I hope this reaction is clear to, this question is clear to each and every one. Let me know in the chats quick. Is this point clear to you? Is this reaction clear to you? Is this reaction clear to you? After that, we will be having another question. Come on. Hydrocarbon A reacts with bromine by substitution to form an alkyl bromide, which by Wirth's reaction is converted to gaseous hydrocarbon containing less than 4 carbon atoms. Now, have a look. First, hydrocarbon A. A is the hydrocarbon, which upon treatment with bromine, that means which reacts with bromine, upon substitution forms alkyl bromide. That means it results in the formation of alkyl bromide. That means this reaction is halogenation, bromination, free radical substitution of alkane. This is hydrocarbon, so this is a free radical substitution of alkane. Now, why I am saying this is alkane? Why I am saying this is alkane? Because it is substitution. If it is alkyne, bromine will be added. That means addition. If it is alkene, bromine will be added. It will be addition. But this is substitution, indicating that it will be either C or D. That means it's an alkane. So, first of all, it will result in the formation of this. So, this is halogenation of alkane. Then, second part of this question is that when this alkyl halide, this alkyl bromide is undergoing Wirth's reaction. Wirth's reaction means it is treated with sodium and dry in presence of dry ether. This is Wirth's reaction. This is Wirth's reaction. But we know when Wirth's reaction of alkyl halide takes place, trick is that just break CX bond, form a radical, then these radicals undergo coupling or combination. That means it will result in the formation of RR. That means it will result in the formation of a compound. But this compound should contain less than 4 carbon atoms. This should contain less than 4 carbon atoms. Have a look. If it is, I mean to say CH4, have a look. If question says what is A? If A is CH4, this will become CH3Br. This will become ethane. That means this is having 2 carbons. If CH3CH3 is this A, that means if this is ethane, this will become CH3CH2Br. What does that mean? The radical formation will be CH3CH2. That upon coupling will give butane. That means having 4 carbons. But question says this should be having less than 4 carbon atoms. That is the reason. Our answer is simply option C. Is this point clear to each and everyone? Is this point clear to each and everyone? Very good. At the rate of Sushmita, at the rate of Rohita, Karthik. Very good. At the rate of Isha, nice. At the rate of Bande, great. At the rate of Rohar, universe, very good. So, which type of reaction is basically this? One is halogenation, another is Wurtz reaction. So, one reaction is halogenation, and another is Wurtz reaction. That means they can combine reactions and give to you. Now, after that, the incorrect method for the synthesis of alkenes. Incorrect method. You have to check. Incorrect method of alkene. That means question came from methods of preparation of alkenes. Now have a look. Treating vicinal dihalide with zinc metal. That means if you are having vicinal dihalide is this one. When it is treated with zinc, you know, zinc is a dehalogenating agent. Here, dehalogenation takes place and it results in the formation of ethene and ZnX2. That means, question says, which is an incorrect method for the synthesis of alkene? This is not incorrect because with the help of this, you can prepare alkene. Next is treatment of alkynes with sodium in liquid ammonia. Treatment of alkyne with sodium in liquid ammonia. Next, heating alkyl halide with alcoholic potassium hydroxide. Listen carefully. Treating alkyl halide in aqueous KOH. Have a look. Treating, I mean to say for example, this is an alkyne. This is an alkyne. Treating alkynes with sodium in liquid ammonia. What will sodium in liquid ammonia do? It will simply replace hydrogen. It will remove hydrogen because it's a strong base. It will remove hydrogen and it will form a double bond over here. Yes or no? That means it can also form alkene. Heating alkyl halide. Simple example of alkyl halide. Let's say like this. Heating it with alcoholic potassium hydroxide. Listen, alcoholic potassium hydroxide means E2 reaction. When E2 reaction takes place, alkene will be formed. But alkyl halide on treatment with aqueous. When it is aqueous KOH, it undergoes at that time, it is simply that reaction in which this acts as a nucleophile. So this is SN2 reaction. What will happen? This X will be replaced by OH. That means alcohol will be obtained with the help of this. So which among these is incorrect? Method to prepare what we call alkenes. Which among these is incorrect method to prepare alkenes? Answer is very simple. It is simply this one. Because with the help of this, you cannot form, alkene. You will form simply what we call alcohol because this is normal SN2 reaction. I hope this is clear. Exactly. Most of the students have given me the right answer, or even I can say everyone has given me the right answer. God bless you. Next question is compound X on reaction with ozone O3 followed by zinc and water. That means this is reductive ozonolysis. Gives formaldehyde. Formaldehyde means this one. And 2-methyl propanol. Propanol is an aldehyde. 2-methyl propanol means at second position it is methyl in propanol. So it is 2-methyl propanol. So this is formed. You have to tell me what is X. We know this is retro. This is retro ozonolysis. So simply replace this oxygen and oxygen, or you just remove this oxygen and oxygen, form a double bond over here. That means this X is actually like this. It is CH2, double bond CH, single bond CH, CH3, and then it is CH3. So when we number this parent chain, it's like this. It is but1-ene to this but1-ene. It's methyl at third position. So it is 3-methyl but1-ene. 3-methyl but1-ene is the correct answer. That means it is option D. I hope this is clear to you. I hope this one is clear to you. Exactly. Everyone try to answer the question. It's not B option. It is this one. It is option number D. It's not B. Because you have formaldehyde means this one, and after that 2-methyl propanol. This is 1, this is 2, this is 3. So this is 2-methyl propanol. Then what you have to do is you have to remove oxygen and form a double bond. That means your alkene, your starting compound from which these two has been formed during reductive ozonolysis is this one. And this is 3-methyl but1-ene. I hope this point is clear to each and everyone. I hope this point is clear to each and everyone. After this. Now, before discussing this question, let me know in the chats if this slide is clear to you. Yes. It's clear on my mobile. That means it's clear to each and everyone. Now, the major product of the following reaction is you are having an unsymmetrical alkene, HBr is there, and peroxide is there. Have a look. This is the reaction. This is the reaction. Very, very simple reaction. Very, very simple reaction. HBr, you have to add on, I mean to say, this alkene which is unsymmetrical in presence of peroxide. So which type of reaction is this? This is peroxide effect, or this is Kharash's effect, or we can simply say this is addition reaction, but in which intermediate is free radical. That means this is free radical addition reaction. So this addition takes place according to anti-Markovnikov's rule. And what is anti-Markovnikov's rule? Negative part of this HBr goes to that carbon-carbon double bond which is having more hydrogens, and positive part goes to that carbon-carbon double bond which is having less hydrogen. So this will be the product. This will be the product of the reaction. Hence, this is our option D. Option B. So the correct answer is option B. I hope this point is clear to each and everyone. So B is the right answer, my dear lovely students. Tell me no. Tell me, beta. Tell me in the chats, is this reaction also clear to you? Is this reaction also clear to you? Someone is saying, why not D? At the rate of Abhinav, D is not possible because it is HBr in presence of peroxide. You have to add HBr in presence of peroxide to unsymmetrical alkene. Always addition takes place according to anti-Markovnikov's product. Addition should take place according to anti-Markovnikov's product. But this is not anti-Markovnikov product, my dear lovely student. I hope this point is clear. After this, there is another question on your screen, and the question is, an alkene on ozonolysis. It's not giving you any information which type of ozonolysis is this, but generally when ozonolysis is not given, whether it is reductive or what we call oxidative, take ozonolysis as reductive ozonolysis. So an alkene on ozonolysis gives methanol as one of the products. What is meant by methanol? Methanol means formaldehyde. Methanol means formaldehyde, and this product can be only prepared from that alkene which contains this part, which contains double bond CH2, then this methanol can be obtained. Now have a look. In this case, it's not double bond CH2. Double bond CH2 is not present in this. Double bond CH2 is not present in D, not present in C. It is only present here, what we call in option B. Hence, option B is the right answer. Hence, option B is the right answer. Option B is the right answer. I hope this point is clear to each and everyone. Okay, that's great. That is great. That is great. You should solve each and every question. You should solve each and every question. Now, question says an alkene A. Alkene A. Question says you have an alkene and that alkene is A. An alkene A. On, once again, question is from, once again, ozonolysis. That means ozonolysis is a very, very, very important reaction. Now, an alkene A on reaction with ozone, on reaction with alkene on reaction with ozone, then zinc H2, that means once again a reductive ozonolysis, gives propanone. Propanone means this one. Gives propanone, means acetone. And ethanol. And ethanol. Ethanol means this one. Ethanol means this one. Now, in equimolar ratio. Now, so you have to, first of all, you have to find out A. Why? Because upon addition of HCl to A, but you can add HCl to A only if you know what is A. So what is A? Retroozonolysis. Simple. Form a double bond over here. So our A alkene is like this. It is CH3, C, CH3, double bond, CH, single bond CH3. So this is beta A. So this is our A. Now, second part of this question says, this alkene on treatment with, this alkene on treatment with HCl or addition of HCl to this alkene gives B. You have to find out what is this B as the major product. So this B as major product is, you have to find out what is this B as major product. So let me erase this and let me show you what is B. Have a look, have a look. But we have to form major product. This is simply electrophilic addition reaction taking place via classical carbocation. That means here intermediate is the carbocation and this reaction is the slowest step of the reaction, hence rate determining step of the reaction. First of all, it will result in the formation of a carbocation like this. It will result in the formation of a carbocation like this. Now, you have to check whether this carbocation undergoes rearrangement or not. But in this case, this is the most stable carbocation, so there will be no rearrangement in this reaction. Now, after that, this Cl minus will attack and it will act as a nucleophile and this is a very fast step. So you will get CH3, C, Cl, CH3 and then CH2, CH3. So this is what we call RB. So this is beta B. So this is B and this is A. So the structure of product B is, you have to find out B. What is B? B is what we call 2-chloro-2-methyl-butane. 2-chloro-2-methyl-butane. It is option number C. 1, 2. 2-chloro-2-methyl-butane. It is this one. It is option C. It is option C. Let me know in the chats quickly, is this point clear to each and everyone? Is this point clear to each and everyone? Exactly C is the right answer. Tell me, tell me, is this clear to each and everyone till now? Is everything clear to each and everyone? Okay, that's great. That is great. Yes, these are basically, today's session is actually PYQs, but which PYQs? NEET PYQs from most repeated organic reactions. So be ready for that, because with the help of these PYQs, every important reaction will be revised. Now, have a look. In the reaction with HCl, an alkene reacts in accordance with the Markovnikov's rule to give a product 1-chloro-1-methyl cyclohexane. The possible alkene is, there are 3 alkenes given and you have to add HCl across carbon-carbon double bond. You have to add HCl across carbon-carbon double bond according to Markovnikov's rule. What is Markovnikov's rule? What is the statement of Markovnikov's rule? Markovnikov's rule says negative part of addendum. That means we have to add this, so this becomes addendum, means molecule to be added. Negative part of this goes to that carbon-carbon double bond which is having lesser number of hydrogen. That means once you break this bond, Cl will be added here and H will be added here. That means from first one, what will be the product? What will be the product if you add what we call HCl to this? Have a look. When you add HCl to this, according to Markovnikov's rule, we know first we have to break, this bond, add Cl to that position, add negative part to that position which is having lesser number of hydrogen. So it is 1-chloro 1-methyl cyclohexane. That means 1-chloro 1-methyl cyclohexane is obtained. What about option B? What about option B? When you add HCl, according to Markovnikov's rule, negative part goes to that carbon-carbon double bond which is having lesser number of hydrogen. That means this one. So the product will be once again like this. CH3, here Cl will be added. So once again, same product is obtained. That means 1-chloromethyl cyclohexane can be obtained from this as well as from this. But if we add HCl to this, it will not result in the formation of 1-chloro 1-methyl cyclohexane. So you have to tell me which alkenes results in the formation of 1-chloro 1-methyl cyclohexane. It is simply, my dear lovely students, it is simply what we call option C. That means both A and B will result in the formation of 1-chloro 1-methyl cyclohexane when HCl is added to A and B. I hope this point is clear. After that, question is there. Another question is there. Another question is there. A very simple question is there. Question says, yes, this is clear. This is clear. Question says, a single compound is given. In the structure of that compound is this, is obtained by ozonolysis. Once again, a question from ozonolysis. Of which of the following cyclic compounds? You have to tell me these compounds upon ozonolysis. Which among these compounds upon ozonolysis will result in the formation of this one? Have a look. What to do? How to check whether this or this alkene was the starting material. Now have a look. If I number this in this fashion, 1, 2, 3, 4, 5, say for example 6. Then at 5 there is double bond O and at 1 there is also double bond O. Now what will I do? Have a look. I will form a structure like this. Let us suppose this is 1. After that 1, it is CH2 at carbon number 2nd. Then at carbon number 3rd, it is CH and CH3. Then at carbon number 4, it is CH2. Then at carbon number 5, it is C double bond O. And this is having CH3 like this. So this is 1, 2, 3, then 4, then 5, then 6. So what we have to do is remove double bond O and double bond O. Remove this oxygen and oxygen and form a double bond between 1 and 5. That means form a double bond between 1 and 5. Let us form a double bond over here. This is 5, this is 6. This is 6, this is 5, and we have formed a double bond between 1 and 5. So obviously this is 2. At 3 there is methyl. That means this is methyl at 3. And after that this is CH2 at 4. Now what is this? This is simply what we call a cyclopentene. And in this cyclopentene there are 2 methyl groups at what we call 1 and 4 position. That means it is option number this. 1, 2, 3, 4. It is option number D. It is simply option number D. So option number D is the right answer. That means it is basically this alkene which upon what we call reductive ozonolysis results in the formation of this compound. I hope this point is clear. So option number D is the right answer. At the rate of Madara, beta, it's not C, it's D. At the rate of Birapa, it's not A, it's D. It's D. I hope this is clear now. I hope this point is clear now. Now, next question is like this. It is the reaction of C6H5. C6H5 means this phenyl ring. This, after that, it is double bond CH, and then CH3. This on treatment with HBr. Now, as this is the addition of HBr, but in absence of peroxide, that means it is a normal electrophilic addition reaction taking place via formation of a carbocation. Now, what will happen? You have to add, say proton first. Br minus will be lost. This step is known as rate determining step of the reaction or slowest step of the reaction. It will result in the formation of a carbocation first. So it will result in the formation of a carbocation. And this carbocation is already stable because of the resonance of this ring. So this is stable carbocation, no need to rearrange this. After that, finally, Br minus will act as a nucleophile. It will attack to this carbocation, and we will get a product like this. We will get a product like this. We will get a product like this. That means it is C6H5, then CHBr, then CH2, then CH3. So it is simply option number D. It's option number D. Option number D is the right answer. So this is electrophilic addition reaction. Now, listen carefully. Among alkenes, either electrophilic addition reaction or HBr to unsymmetrical alkene in presence of peroxide, that means peroxide effect, or ozonolysis. These questions are most, repeated questions. So these reactions are the most repeated organic reactions from which questions are asked from alkenes. After that, in the following reaction, an unsymmetrical alkene is given, and then you have to add water in presence of acid. That means acidic hydration. Once again, electrophilic addition reaction. So in alkenes, electrophilic addition reactions are very, very, very important reactions. Now, what will be A, which is a minor product, and B, here two products will be obtained. A is minor and B is major. You have to tell me here what is major product. B is major product. So you have to tell me B is. You have to tell me what is B. You have to tell me B is. Say what is B, you have to tell me among this. Have a look. This is actually like this. CH3C, CH3, CH3, then it is CH double bond CH2. This, upon treatment with water in presence of acid, that means acidic hydration, it first of all abstracts H positive from acid. Protonation will take place and it will result in the formation of a carbocation. Once again, formation of carbocation is rate determining step of the reaction. So it will result in the formation of a carbocation like this. Now, this carbocation undergoes rearrangement. And here 1,2-methyl carbanion shift takes place, so that it can form more stable carbocation. So it will form more stable carbocation. Finally, water will attack. It will act as a nucleophile now, and it will attack this carbocation. And finally, that will lose H positive. So to this position, OH will be attached. That means it is simply 2-methyl at 3-methyl. That means it is 2,3-dimethyl. After that, 4 carbons, so but and all. That means it is 2,3-dimethyl. Butan 2-all will be the right answer. Now have a look. What will be the right answer? It will be simply option number 1. I hope this point is clear. You have to tell me major product only. Because minor can be another product, which will be simply that H goes to this position, or H can also go to this position. OH can also go to this position, because that can also be formed. But you have to form major one, because major one will be the only one. Okay. After this, my dear lovely students, there is another question, a very, very important question. Now, before discussing this question, first of all, look towards the screen and tell me, is this slide visible to each and everyone? Yes, slide is once again visible to each and everyone. Now, dear students, there is alcohol. Alcohol is given. And after that, it is H positive and heat. That means, in presence of acid, alcohol, in presence of acid followed by heat, that means this is acidic dehydration. Remember this is acidic dehydration. Here two products will be obtained, major and minor. But this major product, upon treatment with HBr in absence of peroxide, that means electrophilic addition. First dehydration, and after that addition, of HBr, electrophilic addition, results in the formation of C and D. You have to tell me the major product, my dear lovely students. You have to tell me major product. One major product is A, which is major product, and you have to tell me after that. Just a moment. First, you have to tell me here major product, And after that, you have to tell me major product of, I mean, say this. That means you have to also tell me, major product here. That means question says this one. Question says you have to tell me A, major product of first reaction and major product of second reaction. That means C, which is a major product. So you have to tell me, in nutshell, you have to tell me what is A and what is C. Now, first of all, what is A? What is A? What is A? Have a look. Have a look. It's simple reaction. Simple reaction. CH3, CCH3. It's H over here. Then it is CH. Then it's OH. Then it is CH3. Once on treatment with H positive, this lone pair will abstract H positive. That means protonation of alcohol first takes place. Once protonation will take place, it results in the formation of CH3, CHOH2 with a positive charge on oxygen. Then it is CH3. Finally, it's a good leaving group. It will leave, water will be lost, and here carbocation formation takes place. This is the rate determining step of the reaction. So first of all, carbocation will be formed over here. So this is the carbocation which will be formed over here. This carbocation undergoes 1,2 hydride shift. 1,2 hydride shift will take place. Now, once hydride shift takes place, it results in the formation of more stable carbocation like this. It results in the formation of more stable carbocation like this, which upon heating finally loses H positive. It will lose H positive from this position and we will get CH3C, CH3, double bond CH, single bond CH3. So this is what we call our A. This is our A. This is our A. I hope this point is clear. After that, this upon treatment with HBr in absence of peroxide. Now, it will add H and first it will result in the formation of a carbocation like this. It will result in the formation of carbocation like this. Finally, Br minus, here Br minus will be lost. This Br minus will now attack to this carbocation and we will get CH3, C, CH3. Here it will be C. Have a look. It is C. Here it is now Br. This is CH3 attached to this. Then CH2, CH3. So this is RB. So this is A. What is A? What is A? A is simply 2-methylbutene. A is 2-methylbutene. That means this is not A, this is A. Or this is A. A and D options are wrong. It may be either B, it may be either C due to this. After that, what is B? B is this one. B is not this one. That means option B is the right answer. Option B is the right answer because this is our A, major product, and this is B, major product. This is B as major product. I hope this point is clear to each and everyone. Exactly, Karthik. Exactly, Karthik. It is option B. Exactly, Karthik. It's option B. Very good. Very good, my dear lovely students. Very good, very good, very good. Very good. After this, question says reaction is given. But is this reaction visible to each and everyone? Let me also check from my mobile. Yes, this is visible. This is visible. Now, once again, an unsymmetrical alkene is there, HBr is there. Now, the question says it gives A, but A is the major product because A predominantly is. That means, what is the major product of this reaction? Question says that. You have to tell me the major product of this reaction. You have to tell me the major product of this reaction. Which reaction is this? Once again, electrophilic addition reaction. Now, have a look. It will result in the formation of a carbocation. It will result in the formation of a carbocation. It will result in the formation of a carbocation. Then, this hydrogen in the form of hydride is shifted. That means 1,2 hydride shift will take place. Finally, it will result in the formation of a carbocation like this. And finally, Br minus will attack this. Br minus will attack this and we will get CBr over here, CH3, CH2, CH3. So it is 2-bromo-2-methylbutane. 2-bromo-2-methylbutane is the option number B. I hope this point is also clear. This reaction is very, very much clear to you. Now, from alkanes, halogenation of alkane is very much important. Yes or no? Decarboxylation reaction is very much important as per alkanes is concerned. From alkenes, it's electrophilic addition, which are very important. Ozonolysis, very important. And peroxide effect, very, very important, because these are the reactions which are basically most repeated reactions. I hope this is clear to you. After that, once again a question from ozonolysis. Which of the compounds with molecular formula, it is C5H10. It is C5 and H10. It is C5H10. Let me write down over here. C5H10, and let me erase this one. C5H10. So, question says, which of the compounds with molecular formula C5H10 yields acetone on ozonolysis? Acetone on ozonolysis. Acetone means this one. Acetone means this one. That means if this is the product of ozonolysis, that means our compound must contain this. Our compound must contain this. Starting compound must contain this. Now, this is 1-butene. Have a look. Have a look. If we talk about 1-butene, what is meant by 1-butene? It is this one. 1-butene. But at 1, 2, 3, third position, it's methyl. It's methyl. So it is 1, 2, 3, and 4. But when this undergoes ozonolysis, it results in the formation of this. Neither this is acetone nor this is acetone. Similarly, cyclopentane, it will not, undergo what we call ozonolysis. After that, 2-methyl but1ene. Once again, this is but1ene, but it is 2-methyl. It is 2-methyl but1ene now. This upon ozonolysis will result in the formation of formaldehyde, and 1, 2, 3, 4 butan 2-on. But we need acetone as one of the products. So this is not the product. This is not the starting material. Now last is 2-methyl. Last is 2-methyl but2ene. 2-methyl but2ene. So when you break this, it will give what we call acetone. So this is the right answer. So this is the right answer. I hope this is clear to each and everyone. I hope this point is clear to each and everyone. After that, dear students, there is another question. There is another question. And question says, reaction of HBr with propene. Reaction of HBr with propene. That means addition of HBr to propene. What is propene? Propene is unsymmetrical. In presence of peroxide. In presence of peroxide. Question says, in presence of peroxide. Whenever peroxide is there, HBr is there, and unsymmetrical alkene is there, you have to add HBr in such a way so that addition takes place according to anti-Markovnikov's rule. That means it is simply 1-bromopropane which will be formed, or this is known as N-propyl bromide. That means this option is the right answer. Option number D is the right answer. I hope this point is also clear to each and everyone. After that, once again a question is from ozonolysis. Have a look. How many questions have been repeated from ozonolysis? How much important ozonolysis is? Have a look. Which alkene on ozonolysis gives this and this? Say one is propanol, another is acetone. Propanol is this one. Propanol is this one. Propanol is this one. Acetone is this one. Acetone is this one. So remove these two oxygens, form a double bond over there. That means the starting alkene is this. Starting alkene is this. And what is the name of this alkene? 1, 2, 3, 4, 5. This is 2-methyl, what we call pent2ene. 2-methyl pent2ene. 2-methyl pent2ene. It's this one. First one. Option number 1. It is option number 1. Is this point clear to each and everyone? Is this point clear to each and everyone? Is this point clear to each and everyone? Come on, quick. These are very, very, very important reactions, because these reactions, with the help of these reactions, you will get an idea which reactions are those reactions which are most repeated organic reactions for your NEET examination. Now, which of the following reagents convert propene? You have to tell me reagent now. Propene to propan-1-ol or 1-propanol. That means you have to add OH here, H here. That means this is addition of water. This is addition of water. This is addition of water, but according to Anti-Markovnikov's rule. What is addition of water according to Anti-Markovnikov? Hydroboration oxidation. Hydroboration oxidation. That means this reaction is basically reagent used should be diborane and then H2O2 in basic medium. Because whenever you saw these types of reagents, this is hydroboration oxidation reaction, and you have to add at that time water across this carbon-carbon double bond. But according to Anti-Markovnikov's rule, and we know hydroboration oxidation is actually that reaction which is indirect hydration reaction. So hydroboration oxidation of alkene means indirect hydration. You have to add water indirectly to carbon-carbon double bond in such a way so that addition of water will be according to Anti-Markovnikov's rule. So it's not first one, it is this last one, but it's not clear. So this is the reagent B2H6 H2O2 in presence of OH minus. So it is this one. It is option number D. I hope this point is clear. So once again, one more reaction is important, and that reaction is hydroboration oxidation, my dear lovely students. Okay. After this, another question. In the following reaction, question is given. Is the slide clear to each and everyone? Yes, this is clear. Now this is propine. Propine on treatment with red hot iron tube at 873 Kelvin gives. We know this. Whenever you are having propine, when propine is treated with red hot iron tube at 873 Kelvin, we know cyclic polymerization takes place and propine will result in the formation of 1, 3 and 5 trimethyl benzene, commonly known as mesitylene. We know this. So which type of reaction is this? It is cyclic polymerization reaction of alkyne. Now, in this mesitylene, you have to tell me number of sigma bonds. Very, very simple. 3 sigma bonds are present in this carbon. Similarly, this one is 4. That means in total, this carbon forms 4 sigma bonds. This forms 4 sigma bonds, 3 with hydrogen, 1 with this benzene ring, phenyl ring. So 4, 4, 8 and 4, 12. 6 are there in this ring. So 12 and 6, 18. 1 is here in the form of carbon hydrogen bond. 1 is here, carbon hydrogen. 1 is here, carbon hydrogen. In total, there are 21 sigma bonds. I hope this point is clear. It is not A. It is option number B. It's not 18 because these are hidden hydrogens. You have to show these hydrogens and you have to count sigma bond of CH bond as well. These CH bonds as well. So there are 21 sigma bonds. After that, the most suitable reagent for the following conversion is this question visible? Yes, this is visible. Most suitable conversion for this. What is this? This is propine. That means this is an alkyne. This alkyne on treatment with, don't know the reagent, but what is given? We know that it results in the formation of this alkene, which is cis. So this is cis alkene. Cis, say but2-ene, or let me write down directly cis alkene. So alkyne, upon addition of hydrogen, because you have added basically hydrogen across carbon-carbon double bond, then cis alkene is obtained. What are the reagents? Remember, what are the reagents? Reagents are, number 1, it is what we call Lindlar's catalyst. It can be PD and C in presence of quinoline, palladium with small amounts of carbon, or it can be palladium with calcium carbonate, CaCO3 with small amounts of sulfur or quinoline. Or you can also use palladium, barium sulfate with small amounts of sulfur or quinoline, or you can use also nickel boride or P2 catalyst. But we have to give answer according to the question. It's not sodium and liquid ammonia because that will give trans. That is Birch reduction. That will give trans. So it is option number B. It's option number B. I hope this point is clear to each and everyone. This point is clear to each and everyone. Yes, exactly. It is option B. It is option B. After that, once again a question is, predict the correct intermediate and product in the following reaction. What is the reaction? Reaction is propyne is here, and among alkynes this is very, very, very important reaction, and this reaction is addition of water to alkyne. That means this is hydration of alkyne. And what is the name of this reaction? Hydration of alkyne. We know hydration of alkyne takes place according to Markovnikov's rule, and it finally first it results in the formation of this one. Have a look. OH goes to that carbon-carbon triple bond which is having lesser number of hydrogen from water, and H goes to that carbon-carbon triple bond which is having more number of hydrogen. So first it results in the formation of enol. This enol undergoes tautomerization. It undergoes tautomerization and it will result in the formation of ketone. So it will result in the formation of ketone. So ketone is the product. So what is the intermediate? This is the intermediate. This is the intermediate. Enol is the intermediate. But this addition takes place according to Markovnikov's rule. And we know this reaction is known as hydration of alkyne, is known as Kocharov's reaction. So this is Kocharov's reaction. So it is simply option A. That intermediate A is this. Yes, this is correct. But B is not this one. That means option A is not correct answer. It is not A. It is not A. This is A, and obviously this is B. So our answer of this question is option C. Option C is the right answer. Option C is the right answer. Very good, very good, very good. Most of the students have given me the right answer. Good, great. Happy for you people. Happy for you people. It's Kocharov reaction. Yes, it is Kocharov reaction. Exactly. After that, in the reaction, once again, reaction is like this. Have a look, have a look, have a look, have a look. Reaction is like this. HC triple bond CH. That means this is a terminal alkyne. When terminal alkynes are treated with strong bases like NaNH2. This is a strong base. So this strong base will simply abstract what we call hydrogen, and it will result in the formation of a carbanion first. That means it will result in the formation of sodium acetylide. This is acetylene, so sodium acetylide will be obtained. Now, after that, this sodium acetylide on treatment with CH3CH2Br. As we know, this is a strong nucleophile. It will attack on this electron deficient site. Br will be lost, and this Na in the form of NaBr, and we will get HC triple bond C, single bond CH2, single bond CH3. If we number it 1, 2, 3, 4, that means it's but1-ine. So it is but1-ine means either A or D. Both these options as per this X is concerned are correct. But after that, this on treatment with once again a strong base, what will happen? Now this strong base will abstract another acidic hydrogen, this one. It will lose, it will result in the formation of NH3 because it will abstract this H. After that, it will result in the formation of this. It will result in the formation of this alkynide like this. So it is like this because it was having acidic hydrogen. Now this will act as a carbanion, it will act as a nucleophile, and it will react further with CH3CH2Br. A very strong nucleophile, it will attack this one and Br will be lost in the form of NaBr, and finally we will get 2 carbons from this side, 2 carbons from this side of carbon-carbon triple bond. So it is like CH2, CH3 over here, similarly CH2, CH3 over here. This is simply 1, 2, 3, 4, 5 and 6. So first is X and this is Y. X is hex 1-ine, but1-ine, and this is hex 3-ine. Hex 3-ine. That means it is option number what we call A. Option A is the right answer. Option A is the right answer. Option A is the right answer. Am I clear? Am I clear? Am I clear till now? After this, another question on the screen is, which of the following organic compounds has same hybridization as its combustion product? As its combustion product. As its combustion product. It is very simple. It's very simple. It is this one, ethine. Because what is the I mean to say hybridization of carbon dioxide? It is sp. It is sp. And among these, which one is sp? It is ethine. Ethine is sp. This is also sp. That means these are having same hybridization. So no need to think much more about this, because this is very simple. Product is also given. Product is given. And question says, whatever is the hybridization of this product, you have to find out the starting material having same hybridization. This is sp. That means you have to find out which one is sp. This is alkane, this is alkyne, this is alkene, this is alcohol, and we know alkynes are sp hybridized. Now, this is very, very simple. Exactly. After this, in the following reaction is given. Now, is this reaction clear to each and every one? Is this reaction clear to each and every one? Yes, this is clear. This is clear. Now, question says, in the reaction, it's not a complete, question. Question says in the reaction. Let me first of all show what is the question. Question is not complete. So we will try to form at least P. Question is like this. This is dilute, obviously, and then Hg2 positive. Once again, this is what we call addition of water, or this is what we call hydration of alkyne, known as Koch-Arrows reaction. So it will result in the formation of this. One, you can add H on one carbon and OH on another carbon. This is enol. And this enol upon what we call tautomerization results in the formation of this one. Now, question is, this is P. Question actually is like this. This P cannot show which of the following tests. This will not give which one of the following tests. That means, let me complete the question. P does not give which of the following tests. So you have to check. P cannot give which of the following tests. First of all, iodoform test. Yes, it can give, because for iodoform test, aldehyde or ketone should be such that which contains this group. So this is having this group, so it can show. Tollens test is shown by all aldehydes, as this is an aldehyde, so it will also be given by this. Brady's reagent test, that means it is 2,4-DNP test. It is given by all aldehydes and ketones, so this will also be given this. But Victor-Meyer's test is given by, my dear lovely students, Victor-Meyer test is basically the test to distinguish 1 degree, 2 degree and 3 degree alcohols, but this is not an alcohol, so our option D is the correct answer. So this will not give what we call Victor-Meyer test, or this will not be identified by means of Victor-Meyer test. I hope this point is clear. Okay, that is great. After this, which of the following reagents will be able to distinguish between 1-butene and 2-butene? Now, 1-butene means this one. This is 1-butene. And what is 2-butene? 2-butene is this one. First of all, what is the difference between these two? This is terminal alkyne. And this is non-terminal alkyne. I hope this point is clear. Have a look. This is terminal alkyne. And this one is non-terminal alkyne. Here, H is attached to Sp. That means this is acidic hydrogen. Here, There is no acidic hydrogen. This is very much acidic. That means these can be distinguished by means of a base, strong base, and that is NaNH2, sodamide. So sodamide will abstract this hydrogen, but it will not abstract, say, hydrogen, this one. So when it is treated with sodamide, it is, say, replaced, and there will be acetylide formation, and acetylide formation results in the formation of a white precipitate. That's why you can use NaNH2. It can form white precipitate, but it cannot form white precipitate even if it reacts with NaNH2. I hope this point is clear. I hope this point is clear to each and everyone. Just a moment, my dear lovely students. Give me a second. Give me a second, my dear lovely students. Okay, beta. Now, is this point clear to each and everyone? Let me know in the chats. Is this point clear to each and everyone? So it is a strong base NaNH2 which can simply distinguish but1 ion and but2 ion. Because on treatment with but1 ion, that means terminal alkyne, it will replace that H, NH2. That means NH2 will simply remove this H, and to that position it becomes C minus and Na positive. That means white precipitate will be formed. I hope this point is clear. After this, predict the product C. You have to predict this one, C, obtained in the following reaction of but1 ion. That means you have a reaction like this: CH3, CH2, C triple bond CH. That means but1 ion is there, and HCl has been added first to this, and you will get B. Now, what is this reaction? It is simply high, what we call addition of HCl. That means it is simply electrophilic addition. So first of all, H positive will be, added, and Cl minus will be lost. Cl minus will be lost, and it will result in the formation of CH3, CH2, then it is C double bond CH, and then it will be CH2, positive charge will be added to this. Finally, Cl minus will attack this one, and it will result in the formation of a product which is according to Markovnikov's rule. I hope this point is clear to each and everyone. So we will get a Markovnikov's product. Negative part goes to that carbon-carbon triple bond which is having lesser number of hydrogen. So it is like this. After this, we have to add HI. Now once again a Markovnikov's addition. So break this pi bond. Let me show you directly with the help of trick. Break this pi bond. Add iodine to that carbon to which halogen is already there. That means this is I, and add H to that carbon-carbon double bond which is already having H. Now it will be the product. So it is 2-chloro-2-iodobutane. 2-chloro-2-iodobutane is the right answer. 2-chloro-2-iodobutane is the right answer. I hope this point is clear. I hope, my dear lovely students, this point is clear. After this, there is another question. Products of the following reaction. Products of the following reaction are. Now have a look. Reaction is like this. It's alkyne. First, this alkyne upon ozonolysis. As it's not written which type of ozonolysis, so it is simply reductive ozonolysis. Now what will you do? Simple. Just break 2 pi bonds, add oxygen double bond to this, double bond oxygen to this. That means first of all we will get a ketone. We will get a diketone like this. This upon hydrolysis now. This bond will be broken, add OH to this, add OH to this. Simple. You have to add this. That means one is CH3COOH, that means acetic acid. And another is CH3CH2COH, that means what we call propanoic acid. So ethanoic acid and propanoic acid is the right answer. First one is acetic acid plus carbon dioxide, no. Second one is CH3COH plus COH, CH3CH2. That means this is CH3CH2COH. Let me write this one over here. This is like this. It is like this. Have a look. Let me erase this one. Let me erase this because I have written this here. Now, After that, dear students, after that, so A is ethanoic acid plus carbon dioxide, B is ethanoic acid and what we call propanoic acid, which is basically the right answer. So this is the right answer. This is aldehyde, no. This is ethanoic acid, and then acetone, no. Option B is the right answer. Option B is the right answer. Let me know quickly, is every question clear till now? Is every question clear till now? Let me know in the chats, quick. Is every question clear till now? Is every question clear till now? Okay, that's great. That is great. That is great. That's like my dear lovely students. Okay, now, my dear lovely doctors, have a look on another question. Which of the following compounds is most reactive in electrophilic aromatic substitution? Now, listen. We know rate of reactivity, or simply reactivity of aromatic compounds. Aromatic compounds towards electrophilic substitution reaction, very important reaction, is directly proportional to what we call decreasing, electron, what we call is directly proportional to electron density, is directly proportional to electron density of the ring, is directly proportional to electron density of the aromatic ring. What does that mean? Directly proportional to electron density of the aromatic ring. What does that mean? That means that aromatic compound whose ring is very electron rich shows electrophilic substitution reaction very fast. So question is, which among these is most reactive? One is phenol, phenol is this one. And we know phenol is having OH directly attached to benzene and it shows plus R. That means because of resonance, it donates electron to the ring and increases the electron density of the ring. Another is chlorobenzene. We know chlorobenzene, in chlorobenzene, this Cl shows two effects. One is minus I, another is plus R, but its minus I is more powerful. That means it deactivates actually ring. It decreases the electron density of the ring. Then nitrobenzene, nitro is minus R, we know. Nitrobenzene is minus R group. That means it is a deactivating group. Then we have three options over here because fourth option is not visible. Let's suppose fourth option is, what we call benzene. Let's suppose fourth option is benzene. Here, it's hydrogen which is attached to this. So among hydrogen, nitro, chloro and OH, which increases the, electron density of the benzene ring? It's phenol. That's why phenol is the right answer. But if it is, say for example, aniline at the end, if it is NH2, then you have to check. NH2 also donates electron to the ring because of plus R, but nitrogen, NH2, shows stronger plus R as compared to OH, then it should be NH2 if it is NH2 at the end. But suppose, our D option is benzene, so our correct answer is phenol. After that, dear students, another question is in front of your screen, is in front of you on the screen. Have a look. It's C7H8, which undergoes following reactions. So first reaction is C7H8 means toluene. C7H8 means this is toluene. It's basically methyl benzene, which on treatment with 3 times Cl2. 3 times Cl2. Yes or no? 3 times Cl2. Then you have to tell me 3 times Cl2, and this is heat actually. This is not D, this is actually heat. Or this is in presence of light. Let me write down light. Let me write down light. Let's suppose, let me change this. Let me change this. Let me write down light over here. Okay. Now, what will happen? What will happen? A very, very simple reaction. This is simply a benzylic, halogenation. So halogenation, free radical, what we call chlorination, will take place at the side chain at the benzylic position. So this is A. Now this A upon treatment with Br2Fe. Now which type of reaction is this? This is simply electrophilic substitution reaction known as bromination. So here Br positive will be generated and it will go to meta position. Why? Because this CCl3 is meta directing group. This is meta directing as with respect to, I mean to say, this is meta directing with respect to electrophile. So electrophile goes to this position. Finally, this is having CCl bond, CX bond, then zinc HCl. What is the function of zinc HCl? It converts CX bond to CH bond. It replaces Cl by hydrogen. So it will result in the formation of toluene. In this toluene, it is bromine at meta position. That means it's meta-bromotoluene, or what we call 3-bromotoluene. It's meta-bromotoluene. It's meta-bromotoluene. I hope this point is clear. I hope, my dear lovely students, this point is clear. Come on everyone, come on everyone, come on everyone. Tell me the answer of this question, quick. Oxidation of benzene by V2O5. Oxidation of benzene by V2O5. Oxidation of benzene by V2O5. By V2O5. At a temperature of, remember, 773 Kelvin. You have to tell me what is the product. V2O5, let me tell you, V2O5 is an oxidizing as well as a dehydrating agent. What will happen? What will happen? Simple. Just try to break this bond and try to break this bond. This carbon is converted to carbon dioxide. This carbon is also converted to carbon dioxide. That means it's twice carbon dioxide. Hydrogen and hydrogen is converted to water. Simple. So here oxidation takes place. This carbon is converted to COH. This carbon is converted to COH. And then these double bonds will be removed and double bond will be formed over here. That means it is like this. Double bond will be formed over here instead of these two double bonds. And this is C double bond O, OH. Carbon, carboxylic acid. C double bond O, OH. This is known as malic acid. Once malic acid is formed, in presence of V2O5, dehydration takes place. That means it will result in the formation of malic anhydride. It results in the formation of malic anhydride. In nutshell, remember, benzene gives malic anhydride. If it is naphthalene, that will result in the formation of phthalic anhydride. But if benzene, oxidation of benzene by V2O5 is given and temperature is given like 500 degrees Celsius, that it results in the formation of phenol. Remember this as well. So what will be the product? It will be malic anhydride. So option B is the right answer. Option B is the right answer. After this question, another question. Which of the following compounds will not undergo Friedel-Crafts reaction? Let me tell you. Limitation of Friedel-Crafts reaction. Remember that limitation of Friedel-Crafts reaction is that whenever any aromatic compound is having meta-directing groups or electron withdrawing groups, whenever benzene ring is having electron withdrawing groups, Friedel-Crafts reaction does not take place at all. Now, xylene means benzene is having two methyl groups. They are electron donating groups. Nitrobenzene means benzene is having electron withdrawing group. Toluene means it's having methyl, electron donating. Cumene, it's having isopropyl, means electron donating. In nutshell, whenever benzene is having electron withdrawing group, at that time ring is what we call deactivated and Friedel-Crafts reaction does not take place at that time easily. After that, among the following compounds, the one that is the most reactive towards electrophilic nitration, once again, most reactive towards electrophilic substitution reaction, for example, nitration, is that aromatic compound which is having electron density highest in the ring. That means that aromatic compound which is attached to electron donating groups. Now, benzoic acid, that means it's benzene and COH, electron withdrawing. Nitrobenzene, that means nitro, electron withdrawing. Toluene means CH3, electron donating. That means if you compare these one is having COOH, it's electron withdrawing, it deactivates the ring. it will not increase the electron density of the ring. NO2, it will decrease the electron density of the ring. Toluene, in toluene, methyl donates electron because of inductive effect as well as hyperconjugation. So it increases electron density of the ring. So more the electron density of the ring, more will be the reactivity of electrophilic substitution reaction, for example, nitration. This is benzene. So if we check out, this is the most reactive among them. Then it is benzene, then it is benzoic acid, and at the end, it is nitrobenzene. So in a nutshell, we have to tell which is most, reactive. It is toluene among these. Among these, it's toluene. Very, very simple question. After that, which one of the following is most reactive towards electrophilic substitution or electrophilic reagent? Once again, in aromatic hydrocarbons, electrophilic substitution reaction. That reaction, questions from that reaction has been asked more repeatedly. So this is the what we call most repeated organic reaction of aromatic hydrocarbon. Once again, you have to check which one of the following is most reactive towards electrophilic reagent. Now, these are, the aromatic compounds. CH3, 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 CH3 is common. After that, it's OCH3, OH, NHCO, CH3 and CH2OH. Obviously, OCH3 shows plus R, OH shows stronger plus R than this, and NHCO, CH3 shows weaker than OH as well as OR. This is CH2OH. It will not show what we call plus R over here. So, the highest electron density will be in that ring in which strong plus R group is there, and we know among OR, OH and NHCO, CH3, it is OH which is strong electron donating group. Hence, it will be simply option number B, which shows what we call electrophilic substitution reaction, or which reacts with electrophilic reagent very, very fast. So this is the answer of the reaction. After that, question says, the reaction of toluene with chlorine, with chlorine in presence of FeCl3, that means in presence of Lewis acid. Listen carefully. Aromatic hydrocarbons on treatment with chlorine, bromine, halogenation in presence of Lewis acid is electrophilic substitution reaction. It is electrophilic substitution reaction. But if aromatic hydrocarbons react with chlorine or bromine in absence of Lewis acid, in presence of light or in presence of heat, at that time it is side chain halogenation. But this is nuclear halogenation. That means electrophilic substitution reaction. Now, this is ortho-para directing. That means here Cl positive, that means electrophile generated on this will attack ortho as well as para position. That means we will get this one. We will get ortho as well as para product, but para one will be the major product. Para will be the major product over here. So the reaction of toluene with chlorine in presence of FeCl3 gives, X. So this will be the X because this is the major one. Because this is the major product. I hope this is clear to you. Now after that, and toluene on reaction with chlorine in presence of light, that means in absence of, in absence of Lewis acid, this is now side chain halogenation, benzylic halogenation. This is free radical substitution reaction. This is nuclear halogenation, electrophilic substitution. This is free radical substitution. This is benzylic or side chain halogenation. So it will result in the formation of. First, benzyl chloride. Then another Cl will replace H. It can form benzyl dichloride. Another H can be replaced and it can finally form benzo trichloride. So it can form this as well if halogen is taken in excess. If halogen is taken in excess, we can get, benzo trichloride during this reaction. Now, the question says, if, say for example, either this is Y or benzyl dichloride is Y or this is Y, it depends on the option. Have a look. So X is benzyl chloride. No, X is not that. Now, X is metachlorotoluene. No, X is not metachlorotoluene. X is ortho and parachlorotoluene. Yes, X is this one. And Y is trichlorotoluene. trichloromethylbenzene. That means this is why. That means chlorine has been taken in excess here. Here, chlorine has been taken in excess. Otherwise, you can say benzyl chloride is formed. You can also say benzyl dichloride is formed. So either this is why or this is why. So our option, I mean to say, C is the correct answer. Correct answer is C. Okay. I hope this point is clear. I hope this point is clear to each and everyone. After that, dear students, benzene reacts with CH3Cl. Benzene reacts with CH3Cl. Benzene reacts with CH3Cl in presence of AlCl3. This is electrophilic substitution reaction known as Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation. Remember this? Friedel-Crafts alkylation. Now, these two will form alkyl carbocation over here. But this methyl carbocation will attack now this benzene and it will result in the formation of toluene. It will result in the formation of a toluene. So, whenever benzene reacts with CH3Cl in presence of AlCl3, its electrophilic substitution reaction known as Friedel-Crafts alkylation, alkyl methyl alkyl group will be introduced into the benzene and the product will be toluene. Product will be toluene. Is this point clear? Is this point clear? Everyone, let me know in the chats quick. Is every reaction clear till now? Is this reaction clear till now? Total duration of this class will be maximum of 4 hours, not more than 4 hours, not more than 4 hours. Okay. Now, have a look. Which one of the following is most reactive towards electrophilic attack? Which one of the following is most reactive towards electrophilic attack? Once again, question from electrophilic substitution reaction. Once again, that ring simply in which electron density of the ring is more. One is phenol. No, one is benzyl alcohol. One is benzyl alcohol. Have a look. It's benzyl alcohol like this. Another is nitrobenzene. You have to check the electron density of the aromatic ring. The aromatic ring whose electron density is more shows, I mean say, this reaction most reactive. Shows this reaction more readily. That means that will be most reactive one. This is chloro. So it will be once again this because of plus R. So once again phenol. Once again a phenol. Very, very simple. Very, very simple. After that, the order of decreasing reactivity. Once again, same question. Question has been repeatedly asked from, I mean say, electrophilic substitution reactions. So one is benzene. Benzene means this one. Another is toluene. Toluene means this one. Another is chlorobenzene. Chlorobenzene means this one. Another is phenol. Phenol means this one. Now have a look. It increases electron density due to resonance. It increases electron density, let us suppose, due to hyperconjugation. It neither increases nor decreases, but it decreases due to minus I. Because its minus I is powerful as compared to its plus R. Now, its electron density will be highest. That means 4 will be first. 4 will be first means either option B or C. After 4, it will be toluene means 2. That means option D is the right answer. Option D, sorry, 4 and 2. That means option C is the right answer. 4 first, then toluene, then obviously benzene, and at the end it will be chlorobenzene. So 4, 2, 1 and 3 will be the answer. 4, 2, 1 and 3. 4, 2, 1 and 3 is the answer. I hope this point is clear. So you have to check only that ring whose electron density is highest. That means that aromatic compound in which stronger electron donating group is attached. Now, which one of the following is a free radical substitution? You have to tell me which one among these is the free radical substitution. First one is addition of HCN2, I mean to say aldehyde. This is nucleophilic addition reaction. Second is benzylic halogenation. This is obviously free radical substitution reaction. Another is electrophilic substitution reaction. This is Friedel-Crafts alkylation reaction. Another is nucleophilic substitution. So this is nucleophilic substitution. Let me write down over here. This is nucleophilic substitution reaction. This one is what we call electrophilic substitution reaction. This one is free radical substitution reaction. First one is nucleophilic addition reaction. What we have to tell? We have to tell free radical substitution reaction. Free radical substitution reaction is obviously option B. Option B. Is this point clear? At the rate of Malik Arjun, no beta, it's not C. It's very simple reaction, it's B beta. It's B. God bless you beta. God bless everyone. God bless everyone. Now after this, predict the order of reactivity of the following 4 isomers towards SN2 reaction. Towards SN2 reaction. For SN2, you must know that rate of SN2 is, if we talk about among 1 degree, 2 degree, 3 degree, say alkyl halides, then it is obviously 1 degree. After that it is 2 degree. After that it's 3 degree. Why? Why is it so? Because rate of SN2 is inversely proportional to steric crowding. It's inversely proportional to steric crowding at alpha or beta position. Now have a look. This is primary alkyl halide. Primary alkyl halide. This one is secondary alkyl halide. This one is also primary alkyl halide. But here crowding is taking place at beta position as compared to this. This is, say alpha position. This is alpha. This is alpha. This is tertiary. So this is 1 degree alkyl halide. This is 2 degree alkyl halide. This is also 1 degree but branched. 1 degree branched means there will be more crowding as compared to this one. This is 1 degree unbranched. So we will write down 1 degree unbranched first. That means 1 first. After that third. 1 third. That means option D. 1 first, third. After that it is second. After that it is tertiary because it will be least. Okay. So 1, 3, 2 and 4. 1, 3, 2 and 4. I hope this point is clear. After that, major product formed in the dehydrohalogenation. What is dehydrohalogenation? That means removal of hydrogen and halogen. This is simply elimination reaction. So the major product formed in dehydrohalogenation reaction of 2-bromopentane. 2-bromopentane is this one. 2-bromopentane is this one. Say for example, this upon treatment with, let's suppose it's alcoholic potassium hydroxide. For example, this one. That means this is simply E2 reaction. Simply E2 reaction. This is alpha, this is beta. Now, this beta and this beta, when we compare these betas with respect to hydrogen, this is having lesser hydrogen, so this is poor with respect to hydrogens, and this is rich with respect to hydrogen. So this base can come, it can abstract hydrogen from this position, rich, and product formed will be like this. Product formed will be like this. CH2 double bond CH, single bond CH2, single bond CH3. And the product formed from rich is known as Hoffman product. And product formed from poor, that means this one. CH3CH, double bond CH, single bond CH2, single bond CH3 is known as Sadzev product. It's Sadzev product. And during this reaction, it says pentuene. Pentuene is this one. It is pentuene. It says reaction major product is pentuene. This is major. This is major and this is minor. And it says this product formation is based on, major product formation is based on Huckel rule? No. Sadzev rule? Yes. Because it is Sadzev's rule. Hund's rule? No. Hoffman's rule? No. It is major product is due to what we call Sadzev's product or Sadzev's rule. I hope this point is clear. After that, elimination reaction of 2-bromopentane to form pentuene is once again same reaction, once again same reaction, once again same reaction. So which type of reaction is this? It is simply elimination reaction because hydrogen has been removed from these beta positions and halogen has been removed from alpha. So it is beta elimination. Yes, it is beta elimination because hydrogen has been removed from beta position. Follows Sadzev rule. Yes, it follows Sadzev rule. It's a dehalogenation reaction. Yes, it is a hydrohalogenation reaction because hydrogen and halogen has been lost. So dehydrohalogenation. But dehydration, it is not dehydration. That means first, second and third, ABC All are correct. A, B, C are correct. A, B, C are correct. That means it is option D. Because you have to choose which one is correct. You have to choose which one is correct. Which one is correct? You have to choose. Question says which one is correct. Question says which one is correct. So it's A, B, and C. After that, which of the following alkane cannot be made in good yield by Wirtz reaction? You should know this one. Alkane which is obtained. Alkane which is obtained by combination of different radicals, during Wirtz reaction. Never form in a good yield. Never form in good yield. And listen carefully, generally such alkanes are unsymmetrical alkanes, means those alkanes which contain lesser number of hydrogens. Generally, they are those. Now, 2,3-dimethylbutane. 2,3-dimethylbutane means this one. 2,3-dimethylbutane is this one. Have a look, beta. If I break this one, it's formed by similar type of radicals, by combination of similar type of radicals. What about heptane? Heptane means this one. CH3, CH2, CH2, 4, 5, 6, 7. It can never be formed by similar type of radicals. Either it is formed by methyl and hexyl radical, or ethyl or pentyl, or propyl and butyl. That means different radicals. It's formed by different radicals. That means this can never be formed in, say, major quantity. It will be always present in low yield. It can never be present in good yield. N-butane. N-butane is this one. 1, 2, 3, and 4. Have a look. This can also be formed from similar type of radicals. N-hexane. N-hexane can also be formed from similar type of radicals, dear students. Have a look. Have a look, beta. This can also be formed from similar type of radicals. So, any alkane which is formed from combination of similar type of radicals are always present in good yield, but that alkane which can never be formed from combination of similar type of radicals, generally unsymmetrical alkanes, generally alkane with odd number of carbons, are not formed in good yield during Wirtz reaction. I hope this point is clear. So Wirtz reaction is very important reaction. Which of the following reactions can be used for preparation of alkyl halide? Now we know alcohol, primary alcohol on treatment with HCl in presence of zinc chloride, anhydrous zinc chloride. This is first reaction. Second is primary alcohol on treatment with HCl. Then tertiary alcohol on treatment with HCl. What we call, this is secondary alcohol on treatment with HCl. Let me tell you. You have to tell me which of the following reactions can be used for preparation of alkyl halides, which can be used for preparation of alkyl halide, which can be used for preparation of alkyl halide. This can be used easily. This can be used easily. This is secondary alcohol. But product here will be formed after some time. Then tertiary alcohol can be used easily. But these reactions cannot be used to form, say what we call alkyl halides. But this can be used only upon heating. So most appropriate answer is this. But if we heat, then you can use also this one. But upon heating, because primary alcohol reacts with HCl in presence of anhydrous zinc chloride, but upon heating, not at room temperature. That means most appropriate can be 3 and 4, but upon heating, it can be 1, 3, and 4 as well. Then 3 and 4 are there, so 1 can also be upon, heating. Otherwise, it can never be this one. Otherwise, it will be this one. So it can be this one if reaction takes place at room temperature, but at high temperature, it can be A as well. That means it can be D, it can be A, depending upon the temperature actually. After that, in an SN1 reaction on chiral center, there is, that means if there is a chiral center, say for example like this is CH3, this is what we call Cl, or let me write down, this is Cl, this is H, this is D. This upon SN1 reaction, during SN1 reaction, if reaction takes place at this chiral center, then what will happen? What will happen? Obviously, backside attack will take place more. That means inversion will take place more as compared to front side attack. That means partial racemization takes place. Partial racemization takes place. We know this. Due to intimate ion pair formation, you should know what is SN1 actually. Now, after that, which one is a nucleophilic substitution reaction? Which one is a nucleophilic substitution reaction? Come on, dear students, come on. Which one is a nucleophilic substitution reaction among the following? First one is addition of water. This is electrophilic addition reaction. Another, next is acid base. This is what we call nucleophilic addition reaction. This is nucleophilic addition reaction. Then, because this is reaction of aldehyde with Grignard's reagent, this is nucleophilic addition. After that, it is conversion of alkyl bromide to amine. This is substitution reaction. HCN is what we call nucleophilic addition reaction. So question says nucleophilic substitution reaction. This is addition. This is nucleophilic addition. This is addition. So it is C, which is substitution. It is C, which is substitution. It is C, which is substitution. I hope this point is clear. I hope this point is clear. I hope this point is clear to each and everyone. I hope this point is clear to each and everyone. Here this R prime, mgx has been added, then mgx will be replaced by H during hydrolysis. That means this is addition, this is also addition, this is also addition, this is substitution. Very, very simple. Very, very, very simple. After that, my dear lovely students, which of the following is least reactive in a nucleophilic substitution? Which one is a least reactive in nucleophilic substitution? Have a look, have a look. This one is vinyl halide. This one is vinyl halide. Option B. Option B is vinyl halide. Whenever you are having a structure in which leaving group is attached to that atom which forms a double bond, that means at that time, dear students, this bond is basically partial double bond. This is having a partial double bond character. Because of that partial double bond character, it becomes strong. And it becomes strong, it's having partial double bond character due to resonance. That means it is difficult to cleave. If this is difficult to cleave, that means it is least reactive towards nucleophilic substitution. So it is this one. So it is this what we call vinyl halide. I hope this point is clear. You know this point easily. After that, reactivity order of halides for dehydrohalogenation. Reactivity order for dehydrohalogenation is better the leaving group, better will be the dehydrohalogenation, means elimination. So we know I minus is better leaving group, after that Br, after Cl, after F, that's Ri, Rbr, Rcl and Rf. Then dear students, it is this question. It is this question now. Very, very simple question. It is this question. This ethyl chloride on treatment with NaCN. What will happen, beta? What will be the major product? Cl will be replaced by Cn. So this will be the major product. Cl will be replaced by, I mean to say Cn. So this will be the major product. This will be X. After that, this X on treatment with H2Ni, that means it is addition reaction. So we will break this one. We will add hydrogens. So reduction of cyanide by using catalyst, that means catalytic reduction, results in the formation of a primary amine. So cyanides upon reduction gives primary amine, and this primary amine is what we call Y. Now this Y upon treatment with acetic anhydride, have a look. This on treatment with acetic anhydride. This on treatment with acetic anhydride. What you have to do is, you have to remove one hydrogen. replace one hydrogen by acetyl group. This is acetylation reaction, simple. So CH3, CH2, CH2, NH is there. Instead of one H, write C double bond O CH3. So it is acetylation reaction. So it is CH3, CH2, CH2, CH3, CH2, CH2. Then it is NH. CH3, CH2, CH2, NH. Then it is CO, CH3. That means it is option number 1. It is option number 1. All options are not clear, but we have formed the product. So option number 1 is the right answer. Option number 1 is the right answer. Tell me, beta. Tell me, beta. Tell me, beta. Are these reactions, are these questions clear to you? Are these reactions and questions clear to you? Now after that, it is CH3, CH2, CHCl2. That means it's a geminal dichloride. Is treated with NaNH2. Whenever geminal dichloride is treated with strong base or vicinal dichloride is treated with strong base, remember, geminal dichloride or vicinal dichloride is treated with strong bases like alcoholic potassium hydroxide followed by NaNH2 or NaNH2 directly, then it will result in the formation of alkyne. It will result in the formation of alkyne containing same number of carbons. That means it will result in the formation of propyne. And propyne is this one. This is propyne. Basically, what has happened, have a look. Actually, first of all, we know, there will be dehydrohalogenation. First of all, there will be E2 reaction. That means alpha will lose halogen and beta will lose hydrogen, and it will result in the formation of vinyl chloride first, like this one. Vinylic halide will be formed first. Vinylic halide will be formed first. After that, once again, NaNH2 will lose HCl. That means Cl from this position, H from this position, and it will result in the formation of propyne. It will result in the formation of propyne. So propyne will be the major amine say product. After this, which of the following is suitable to synthesize chlorobenzene? Is this slide clear to you? Is this slide clear to you? Let me know quickly. Is this slide clear to you? Yes, this is clear. Yes, this is clear. Yes, this is clear. Now, which of the following is suitable to synthesize chlorobenzene? It is very, very simple. Last reaction. Benzene on treatment with chlorine. Have a look. It's benzene. Benzene on treatment with chlorine in presence of anhydrous FeCl3. Anhydrous FeCl3. Very, very simple reaction. It's electrophilic substitution reaction, halogenation reaction. So we will get chlorobenzene. We will get chlorobenzene. This is the very, very, suitable method to synthesize chlorobenzene. Very simple method to synthesize chlorobenzene. I hope this point is clear. So it is option D. So it is option D. It is option D. After that, the hydrolysis reaction that takes place at the slowest rate among the following is, at the slowest rate among the following, it will be obviously B. Why B? Because here it is very difficult to replace this Cl due to partial double bond character as a result of resonance. As a result of resonance. So this removal of Cl by ONA is difficult, because here Cl is directly attached to aromatic ring, and we know this is haloarene, and haloarenes do not show nucleophilic substitution reactions very easily because their CX bond is very difficult to cleave, because that CX bond is very strong due to their partial double bond character as a result of resonance. After that, which of the following compounds undergoes nucleophilic substitution reaction most easily? Most easily, nucleophilic substitution reactions. Remember, this is basically chlorobenzene, 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 and to these chlorobenzene, this is NO2, electron withdrawing group. This is CH3, electron donating, OCH3, electron donating. We know in case of haloarenes, when electron withdrawing groups are attached to benzene ring, or whenever electron withdrawing groups are attached to benzene ring, they are more susceptible towards nucleophilic substitution reactions. That means nucleophilic substitution reaction will be much faster in this because of presence of NO2. Because of presence of NO2. I hope this point is clear. After that, the correct order of increasing reactivity of CX bond towards nucleophilic substitution. Once again, towards nucleophilic substitution. First one is chlorobenzene. Second one is chlorobenzene in which two nitro groups are present. Third one is, let me write down over here. First one is chlorobenzene, and chlorobenzene means it is what we call haloarene. And second one is once again a same chlorobenzene, but to that NO2, two NO2 groups are present, obviously at ortho and para position. Then it is this one. It's alkyl halide. It is alkyl halide. Then it's once again an alkyl halide. You should know this point. First of all, you should know alkyl halides are more reactive. Alkyl halides are more reactive as compared to aryl halides towards nucleophilic substitution reaction, because their CX bond is easy to break as compared to CX bond of this, due to partial double bond character as a result of resonance. Because these are having partial double bond character. But among these, it is this one. Among these, it is this one. Among these, it is this one, because when electron withdrawing groups are attached to this, it's what we call reactivity towards nucleophilic substitution will be increased. So if this is one, this is second, one will be always at, say it will be least reactive, and after that this will be more reactive than this one. But among these, it will be this one. It will be, this is 3 and this is 4. So remember, it will be this one and this will be the most reactive. This one will be the most reactive. That means it is 1, 2, then 4 and then 3. 1, 2, 4 and 3. Because among these, reactivity is directly proportional to what we call stability of carbocation. It can form more stable carbocation, hence it is more reactive. So this is less reactive and then this. That means if I put a, what we call, it will be like this. So these both are less reactive than this and this, but this is less reactive than this. This is most reactive. Most reactive is third, then it is 4, then it is 2, then it is 1. So most reactive is, third, then it is 4, yes, then it is 2, then 1. Yani 1, 2, 4 and 3. I hope this point is clear. Then next question is, consider the following reaction and identify the product. You have to identify the product. Now, is this slide clear to you? Yes, this is clear. Now have a look. What is this? This is basically alcohol. So this is alcohol. Let me write down this one. This is alcohol. This alcohol on treatment with, this is a secondary alcohol. Secondary alcohol or tertiary alcohol on treatment with HBr undergoes reaction via SN1 mechanism. That means OH will abstract a proton. It will get protonated first. So protonation of alcohol will take place first. So it will be protonated alcohol formation first. Now, this is a good leaving group. It will leave. Once it will leave, what will be the product? What will be the carbocation? This will be the carbocation. After that, 1,2 hydride shift will take place. 1,2 hydride shift will take place. And once 1,2 hydride shift takes place, it forms a carbocation like this. Finally, Br minus will attack. Br minus will attack to this position. When Br minus attacks this position, that means our answer of this question will be option number 1. It will be CH3C, CH3, Br. That means it will be like this. Here it will be Br. So it will be this, then CH2, CH3. That means it is 2-bromo, 2-methyl-butane. 2-bromo, 2-methyl-butane. 2-bromo, 2-methyl-butane. So option number 1 is the right answer. Is this point clear? Is this reaction clear? Is this reaction clear to each and every one? Very, very simple reaction. Very, very simple reaction. After that, which among the following will be the most readily dehydrated under acidic conditions? Which will be most easily dehydrated? You know, that OH will be easily dehydrated. Which can form most stable carbocation. And we know most stable carbocation can be formed in this one. Because here it is NO2, electron withdrawing, electron withdrawing, electron withdrawing. And here it is OH, it's not that much electron withdrawing. That's why it will form this one, because this will form a more stable carbocation after removal of OH. So it is this one. So remember, rate of dehydration of alcohol is directly proportional to stability of the carbocation formed in RDS. So that's why it is option number B. After that, given below are two statements. Statement 1, in low-cost test, primary, secondary and tertiary alcohols are distinguished on the basis of their reactivity with concentrated HCl zinc chloride known as low-cost reagent. Exactly correct, because this is known as low-cost test. Low-cost test helps to distinguish primary, secondary and tertiary alcohol. Exact, right one. Then second, primary alcohols are most reactive and immediately produce turbidity at room temperature. No, wrong. That means statement 1 is correct, but statement 2 is incorrect, because it is tertiary alcohol which is more reactive. So statement 1 is correct, but statement 2 is incorrect. So it is option number B. It is option number B. It is option number B. Exactly. Option B is the right answer. Tell me, what is the IUPAC name of the organic compound formed in the following chemical reaction? It is acetone. Reaction is like this. Acetone. Acetone means this one. This on treatment with C2H5MgBr. We know this is Grignard's reagent. In presence of dry ether, here it will act as a nucleophile. It will attack this one and it will form an addition product or adduct like this. So this will be the adduct. This will be the adduct. It will be O minus MgBr. Finally, upon hydrolysis, what will be the product formation? Finally, upon hydrolysis, this OMgBr is converted to OH. That means it is like this. Can I write C2H5 in this fashion? CH2, CH3. So this is simply 1, 2, 3, 4. 4 carbons are in a chain. So this is a substituent. So 2-methyl-butanol, 2-methyl-butanol, 2-methyl-butanol is the option number 1. Option number 1 is the right answer. I hope this point is clear. I hope this point is clear. Next, when vapors of secondary alcohol is passed over heated copper. Very, very simple question. Vapors of secondary alcohol. Secondary alcohol means this one. Secondary alcohol means this one. Secondary alcohol means this one. This upon treatment with copper at a temperature of 573 Kelvin. Remember, primary alcohol undergoes dehydrogenation, results in the formation of aldehyde. Secondary alcohol undergoes dehydrogenation, resulting in the formation of ketone. Tertiary alcohol undergoes dehydration. But this is secondary alcohol. Break this bond, break this bond. Oxygen and carbon will form double bond. That means we will get acetone. That means ketone, dimethyl ketone, propanone, whatever name you like. Now, plus hydrogen. That means it is dehydrogenation plus ketone. So it will result in the formation of a ketone. I hope this point is clear. After that, in the following sequence of reactions, now reaction says it is CH3Br. It is CH3Br. After that, it is KCN. That means it is simple. Major product will be simply CH3CN. Major product will be this. That means this is the major product. Cyanide. Upon hydrolysis, cyanide yields carboxylic acid upon hydrolysis. That means convert this into COOH. But if it is written that partial hydrolysis of cyanide takes place, then it is amide. If it is not written, so hydrolysis means complete hydrolysis, that means carboxylic acid. But if it is written partial hydrolysis, then it is what we call amide. I hope this is clear. That means upon hydrolysis, it can be, say carboxylic acid, it can be amide as well. Yes or no? But it is not written. It is not written whether it is, say partial hydrolysis or complete. So let's take it as complete hydrolysis. I hope this point is clear. Now this upon lithium aluminium hydride, this upon treatment with lithium aluminium hydride. That means it's a reducing agent. Just break this, add H to this, add H to this, break this, add H to this, add H to this. So it becomes CH3, CH2OH. So this is the final product. Ethyl alcohol or ethanol will be the final product. So it is ethyl alcohol. I hope this point is clear. So this is C. Now, another reaction is ethanol. Ethanol means this one, CH3CH2OH. On treatment with PBr3, have a look. PBr3, that means alcohol on treatment with this, what will happen? Replace this OH by Br. Replace this OH by Br. That means it will be simply ethyl bromide. This is X. This X on treatment with, it is alcoholic KOH. If it is aqueous KOH, then it is SN2, but it's alcoholic KOH, so it is E2. Just remove halogen from alpha and hydrogen from beta. That means dehydrohalogenation reaction takes place and it will result in the formation of Y. That means alkene. This alkene on treatment with H2SO4, listen carefully. This is simply electrophilic addition reaction. That means it will form first a carbocation by addition of hydrogen, and finally OSO3H will be added. It results in the formation of alkyl hydrogen sulfate. But this alkyl hydrogen sulfate on treatment with water and heat, that means boiling water or heat, upon heating, it will replace this OSO3H by OH, and the final product will be once again ethyl alcohol or ethanol, CH3CH2OH. That means it is this option number C. It's option number C. This is CH3CH2O, CH2CH3, no. CH3CH2O, OSO3H. It can be formed, but if there is no water and heat. But if it is water as well, then it is alcohol formation. After this, dear students, ethylene oxide. Ethylene oxide means this one, beta. On treatment with Grignard's reagent, Grignard reagent means this one. This is negative, this is positive. What will happen? What will happen? Have a look. Have a look. In presence of dry ether, this is simple nucleophilic substitution. It will attack, say for example, this carbon, and this bond will be broken. That means it forms R, CH2, CH2O minus. It forms R, then CH2 and CH2. Because there are two carbons, CH2, CH2, then it's O minus, then it is O minus MgX. This upon hydrolysis converts this OMgX into OH. That means it results in the formation of CH2, CH2, OH. I mean to say here it results in the formation of primary alcohol. So here primary alcohol is obtained. I hope this point is clear. Beta. Okay. After this, which of the following will not form a yellow precipitate? Will not form yellow precipitate on heating with an alkaline solution of iodine. That means which of these cannot form? First of all, these are all alcohols. Which alcohol can form? Yellow precipitate, that means iodoform. Let me tell you, this can form. Any alcohol having this group on treatment with iodine, NaOH, forms CHI3. That means yellow precipitate. Now the question is, which cannot form? Have a look. This is having CH3CHOH, that means it can show. This is also having CH3CHOH, that means it can also show. This is also having CH3CHOH, that means it can also show, but it cannot show. So question is, which cannot form yellow precipitate? It is methanol. I hope this point is clear. So this reaction is from iodoform test, haloform reaction simply. N-propyl alcohol and isopropyl alcohol. N-propyl alcohol is this one. N-propyl alcohol is this one. Isopropyl alcohol is this one. These two can be distinguished by which reagent? Simple. This is having CH3CHOH group. This is not having. So it will show iodoform reaction. It will not form iodoform reaction. Very, very simple. Yes or no? But iodoform is not, here, option. So we will not use iodoform. Then PCl5, no. Then reduction, no, it's simply oxidation, because upon oxidation by using strong oxidizing agent, it finally forms CH3, CH2, COH. That means it forms a carboxylic acid. Upon treatment with strong oxidizing agent results in the formation of a ketone. So with the help of this oxidation with potassium dichromate, that means by using strong oxidizing agent, you can distinguish primary alcohol and secondary alcohol. I hope this point is clear. Now, match the reagents list 1 with the products list 2 obtained from phenol. That means when phenol is treated with NaOH-CO2, phenol on treatment with NaOH-CO2, this is Kolbe's reaction, and we will get salicylic acid. That means A4. That means it can be C or D. B and C can never be the option. After that, phenol on treatment with aqueous NaOH chloroform, this is Reimer-Tiemann reaction. That means B will give 3, B gives 3, A4B3. That means it is this one. A4B3 gives this one. After that, phenol on treatment with zinc dust gives benzene. It is this one, second. So C is second. After that, phenol upon oxidation by using sodium dichromate, strong oxidizing agent, gives benzoquinone. That means D gives 1. So obviously it is option number D. After that, which of the following cannot be used to prepare phenol? Now, first reaction is benzene. On treatment with oleum, that means fuming sulfuric acid. That means H2SO4 plus SO3. That means H2H2S2O7. So it will result in the formation of sulfonic acid. This sulfonic acid on treatment with NaOH first results in the formation of sodium salt of what we call sulfonic acid. Then that sodium salt of sulfonic acid forms what we call sodium phenoxide. First it will result in the formation of sodium salt. SO3Na. Then it results in the formation of, upon heating, it results in the formation of sodium phenoxide. This sodium phenoxide upon treatment with H3O positive results in the formation of phenol. That means phenol can be obtained over here. So phenol can be obtained from this. Aniline NaNO2 HCl heating. Now this is diazotization reaction. Here we get what we call benzene diazonium salt first. Then upon heating with water also gives what we call phenol. Have a look. That means aniline on treatment with NaNO2 HCl first results in the formation of benzene diazonium salt, like this, say for example. Then this on treatment with water and heat, this N2 will be replaced at that time by OH, so it will also result in the formation of phenol. Then cumene is isopropyl benzene. That means isopropyl benzene. This upon oxidation at a temperature of 368 to 408 Kelvin, dear students, resulting in the formation of cumene hydroperoxide first. Cumene hydroperoxide is formed first. And this cumene hydroperoxide upon acidification at a temperature of 323 to 363 Kelvin approximately results in the formation of phenol and acetone. That means phenol is also obtained in this. But this is what we call NaOH, but at STP, not under drastic conditions. So under drastic conditions, this can form only what we call phenol. Otherwise, under normal conditions, we know haloarenes do not show nucleophilic substitution reactions under normal conditions. So it is this one. We cannot prepare phenol from chlorobenzene under normal conditions. Yes, we can prepare phenol from chlorobenzene by treating chlorobenzene with NaOH, but at high temperature, 623 Kelvin, 300 atmospheric pressure, followed by acidification known as Dow's process. But this is not that. This is under normal conditions. That's why it is option number D. After this, the structure of intermediate A in the following reaction. This is cumene. Upon oxidation, it gives, have a look, it is this one. Cumene upon oxidation gives this one. This is cumene hydroperoxide. So this is A of this reaction. Cumene hydroperoxide. That means it is this one. It is cumene hydroperoxide. Let me know in the chats Am I clear till now? Let me know quickly. Let me know quickly, beta. Am I clear till now? Am I clear till now? Let me know in the chats quick. Let me know in the chats quick. Okay. In the reaction phenol chloroform NaOH, it results in the formation of this. The electrophile is, which type of reaction is this? This is Riemann-Tiemann reaction, simply. Riemann-Tiemann reaction is having an electrophile known as dichlorocarbene. Is known as dichlorocarbene. How this is Riemann-Tiemann reaction? Because upon acidification, it gives salicylaldehyde. So this is Riemann-Tiemann reaction, and this is the intermediate of that. And electrophile of the reaction is dichlorocarbene. Very, very simple reaction. After that, compound A is found to, whose formula is C8H10O, is found to react with NaOI. That means it is I2NaOH produced by reacting Y with NaOH. That means NaOI is produced by reacting iodine with NaOH. That means Y is iodine, Y is iodine, Y is clear, Y is clear, then and yields a yellow precipitate. Yellow precipitate means iodoform. And you have to check which among these can form iodoform. These are all OH, containing compounds. Then that OH containing compound can give iodoform test, can form iodoform on treatment with NaOI or NaOH iodine, which contains this group, CH3CHOH group. Any hydroxy compound which contains this group on treatment with NaOI or on treatment with iodine NaOH gives yellow precipitate. That means our option here is simply D, because this is having CH3CHOH, this group. So, and iodine. This is not having CH3CHOH group. This is not having, so it is option D. After this, identify the major products P, Q, R in the following reaction. Now, first reaction. What is first reaction? First reaction is this one. Friedel-Crafts alkylation reaction. First reaction is Friedel-Crafts alkylation reaction. What will happen? First of all, it will result in the formation of AlCl4- will be lost. It will result in the formation of this one. This is the carbocation which is first formed. But this carbocation can undergo rearrangement. It can undergo rearrangement. Once it undergoes rearrangement, then it will result in the formation of a carbocation like this. Finally, this carbocation is added to this benzene ring because it attacks benzene ring. And finally, when it attacks benzene ring, we will get isopropyl benzene. We will get isopropyl benzene. This isopropyl benzene is P. This upon oxidation followed by hydrolysis gives phenol and acetone. It gives phenol and acetone. Now, one is Q, another is R. You have to tell me P, Q, R. What is P? P is isopropyl benzene. This is not isopropyl benzene. This is not this or this. These two are P. Then Q is phenol and acetone. Phenol, but this is not acetone. So it is option C. It is option C. One isopropyl benzene known as cumene, then phenol, then say acetone. I hope this point is clear. I hope this point is clear. Have a look. This reaction is the most repeated organic reaction from which question has been asked from NEET. Reaction of phenol with chloroform in presence of dilute sodium hydroxide finally introduce which one of the following functional groups? Which type of reaction is this? When phenol reacts with chloroform in presence of base, which type of reaction is this? This is Riemann-Tiemann reaction. And in Riemann-Tiemann reaction, what is the major product formed? Salicylaldehyde. What is salicylaldehyde? That is phenol in which CHO group has been introduced. That means it is 2-hydroxybenzaldehyde. So it is aldehyde group which has been introduced. So it is this one, CHO. After that, among the following sets of reactants, which one produces anisole? Which one produces anisole? It is very simple reaction. It is this one. Why? Because NaOH on treatment with phenol first forms. Have a look. Phenol is acidic in nature. It loses H positive when treated with NaOH. Have a look. OH minus will lose, will abstract this H. So it will lose H positive and forms phenoxide. Once phenoxide is formed, this on treatment with CH3I, I mean say alkyl iodide, normal SN2 reaction known as Williamson synthesis takes place. Williamson ether synthesis takes place, or Williamson synthesis will take place. Williamson synthesis means reaction of alkoxide or phenoxide with alkyl halide, formation of ether takes place. So it is this reaction. Here it will be ferric phenoxide. It will not be, I mean say this anisole, because this is anisole, methyl phenyl ether. Anisole will not be formed over here. This will be nucleophilic addition. Alcohol will be formed, not anisole. Here, this is what we call acetylation reaction. It is acetylation, it's electrophilic substitution reaction. So there will be no ether formation at all. So ether formation, that means anisole formation, will be because of B. After that, which of the following will not be soluble in sodium hydrogen carbonate? What is meant by that? That means which of the following cannot show sodium bicarbonate test? And we know sodium bicarbonate test is shown by those acids which are stronger than H2CO3. And which type of acids are these? These are, say for example, squaric acid. These are picric acid is there. Sulfonic acid is there. Remember. I'm not giving it in, say acidic strength order. I am giving it in general. That means squaric acid, picric acid, sulfonic acid, carboxylic acid. Dinitrophenols. These are stronger acids than what we call carbonic acid. So these can simply give sodium bicarbonate test, or it can react with sodium bicarbonate and there will be carbon dioxide, brisk effervescence will take place. But there is one weaker acid. There is one weaker acid than phenol, and that weaker acid is paranitrophenol. This also shows this test. But this is the only weaker acid than carbonic acid which can show this test. Otherwise, acid should be stronger. Now, this is 2,4,6 trinitrophenol, means picric acid, so it can show. Benzoic acid, that means carboxylic acid, it can show. Orthonitrophenol, it cannot show. Benzene sulfonic acid means sulfonic acid, it can show. So the question is, which of the following will not be soluble? That which cannot show the reaction is not soluble. That means it's orthonitrophenol. It's orthonitrophenol. After that, phenol is distilled with zinc. Phenol is distilled with zinc. That means phenol is treated with zinc. Obviously, when it distilled with zinc, it results in the formation of benzene. Now, followed by Friedel-Crafts alkylation with propyl chloride. That means this one, CH3, CH2, CH2Cl in presence of AlCl3. We know first it forms N-propyl carbocation which undergoes rearrangement, and finally it forms isopropyl carbocation, and that isopropyl is introduced into the ring. So isopropyl benzene will take place. That means cumulene will be the formation of the product. So this is the compound B. This is the compound B. Okay. B is oxidized in presence of air. This is oxidized in presence of air. In air. Okay. To form compound C. This is oxidized in presence of air to form compound C. Compound C is simply this one. Compound C is simply this one. It is isopropyl. This is what we call cumene hydroperoxide. So this is C. Cumene hydroperoxide is C. So what is C? Formula of C is this one. It is this one. C, CH3, O, and H. I hope this point is clear. This reaction has been repeatedly asked. Remember this. After that, phenol on treatment with zinc at dust. Once again, this similar reaction. So it is benzene. Then benzene on treatment with methyl chloride. Have a look. First, phenol on treatment with zinc dust gives benzene. This benzene on treatment with CH3Cl, AlCl3. That means it is Friedel-Crafts alkylation. It is Friedel-Crafts alkylation. Then this Friedel-Crafts alkylation, this methyl benzene on treatment with KMnO4 alkaline followed by acidification converts this into COH. Converts this into COH. That means benzoic acid will be obtained. Benzoic acid will be obtained. After that, when phenol is treated with chloroform and NaOH, once again, phenol, chloroform, NaOH, this is known as what we call Raman-Tiemann reaction, and salicylaldehyde is the major product. So salicylaldehyde is the major product. Very, very simple reactions. After this, consider the following reaction. Reaction is there. Reaction is there. Have a look, have a look, have a look. Reaction is there. Now, on treatment with HI, as you know, this is aromatic ether. Oxygen is attached to aromatic ring on one side. Then this bond will be broken. Give H to this, I to this. So whenever aromatic ether is treated with HI, such type of aromatic ether on treatment with HI, always one of the products will be phenol and another will be benzyl iodide. That means it will be this one. It will be this one. This is a very, very, very important reaction. Very important reaction, my dear lovely students. Exactly. Exactly. It is C. It's not A. Yes, it's C. Yes, it's C. After this, anisole on cleavage with HI. Very important reaction. Have a look. Anisole is this one. That means once again an aromatic ether is this. Aromatic ether is this. Yes or no? This on treatment with HI and heat, cleavage. Now break this bond, break this bond. Because whenever oxygen is directly attached to ring, you have to break other bond. If that is also aromatic ring or that is the carbon having double bond, then that bond will not also broken. Now, so this bond will be broken. Give H to this, I to this. That means phenol and what we call methyl iodide. Phenol and methyl iodide. Phenol and methyl iodide is the option D. Very, very simple reaction. Now, major product formed from this. Major product formed from this. Have a look. Have a look. This is an unsymmetrical ether. One side it's having tertiary alkyl part, another side is not having tertiary alkyl. When one side is tertiary, another is not tertiary, or one side is that group which can form more stable carbocation, just break that bond. Break that bond. Just break that bond. Break that bond. Give I to this. Give I to this. Give H to this first. Then, but HI is taken in excess. When HI is taken in excess, then break this bond also. Give H to this, give I to this. That means it results in the formation of CH3, CH2, CH2I, and here it will be also tertiary butyl iodide. So it will be option number B. But if it is not taken in excess, then this part will become alcohol and this part will become iodide. I hope this point is clear. I hope this point is clear. After that, identify A and B and predict the type of reaction. Predict the type of reaction. Now, have a look. Have a look. Have a look. What will happen? NaNH2. It's a base, strong base. It will abstract this hydrogen. It will simply remove this hydrogen. When it removes this hydrogen, it will result in the formation of this one. It will result in the formation of this one. It will result in the formation of this one. Now this can form a triple bond over here. That means benzene mechanism takes place. It will be like this. Yes or no? Yes or no? But here, now attack can be of, say NH2 minus, because it's Na positive, NH2 minus. It can attack either here, let's suppose this is attack A, then it will result in the formation of this. Then it will result in the formation of this. Have a look. And we can say it can take attack B. That means it can attack this carbon as well. This carbon as well. At that time, this bond will be broken. So what will be the product of B? Product of B will be like this. Here it will be NH2 and here it will be negative charge and then Na positive. But this is more stable because of this negative charge is more stable due to these electron withdrawing groups as compared to this one. If this is more stable, product will be formed from this. Finally, this negative charge will abstract H. That means product will be this one. Product is this one, and this is a normal substitution. This is normal substitution because leaving group leaves, nucleophile comes. That means it is normal nucleophilic substitution reaction. That means one product will be this, and this is a normal substitution. Yes or no? And if product was this is sine substitution. Because here, what has happened basically here, in this case, nucleophile goes to that position which is adjacent to the leaving group. That is known as sine substitution. Product formed from this will be sine substitution, but that will be less stable. That will be, say minor product. You have to tell major product. So major product is this, and this is a normal substitution reaction. Now, after this, reaction is like this. If you are having an alcohol like this, this on treatment with base, what will happen? This on treatment with base, what will happen? It simply results in the formation of this one. This on treatment with CH3I, and it gives this one. It results in the formation of ether. Reaction of alkoxide with ether, with alkyl halide to form ether is known as Williamson synthesis. Which one? Williamson ether synthesis. Williamson alcohol synthesis? No, Williamson ether synthesis. Because ether has been formed. After that, another reaction is this one. Once again, it's alkoxide. This is what we call alkyl halide. It will attack this, and Cl minus will be lost. Once again, reaction of alkoxide with alkyl halide resulting in the formation of ether. Is known as Williamson ether synthesis or Williamson synthesis. Williamson continuous etherification? No, it is Williamson synthesis or Williamson ether synthesis. I hope this point is clear. After that, identify Z. Have a look. It is simple. It is a reaction of this alkene with HBr in presence of H2O2. That means peroxide. So it is peroxide effect. So what will happen? CH3, CH2, Br will be formed. That means anti-Morkonikoff's product will be formed. So this is why. This on treatment with C2H5O minus Na positive. This is normal SN2 reaction, Williamson synthesis. So it will result in the formation of what? CH3, 1, 2, 3, CH2 whole 3, then it is OC2H5 or OCH2CH3. That means option number 1, CH3 CH2 whole 3, OCH2CH3. This will be the right answer. Am I clear, beta? Am I clear? After this, dear students, among the following ethers, which one will produce methyl alcohol on treatment with hot concentrated HI? You have to tell me which among these can form methyl alcohol. Methyl alcohol will be formed only if cleavage of oxygen and methyl group does not take place. That means cleavage of oxygen and this group should take place, then it will form this one, because this reaction, this is tertiary alkyl on this side. In this, there will be no tertiary alkyl. There is no tertiary alkyl. So this reaction takes place by SN1 reaction. That means it forms more stable carbocation first. That's why I goes to this one. In SN1, I goes to, larger alkyl group. If alkyl groups are present on both sides of ether and both alkyl groups are unsymmetrical, but one is tertiary, another is not tertiary, at that time reaction takes place by SN1 and it will be the option this. So methyl alcohol will be obtained here. After this, in the reaction is once again, but this reaction is with HI and heat. Remember, no one among these alkyl groups is what we call tertiary. So this will be SN2 reaction. SN2 reaction means smaller alkyl group and oxygen will be broken, and I will go to this. But if it is not taken in excess, this will be the product. But if HI is taken in excess, then this bond will also be broken. I goes to this one. Now, have a look. So we will get CH3, CH2OH. That means this one. Yes. After that, CH3, CH2I. That means we will get option C. CH3, CH3, CH2OH, and then CH3, CH2I. I hope, beta, this is clear to you. I hope, beta, this is clear to you. I hope, beta, this is clear to you. After that, major organic product in the reaction. Major organic product in the reaction. But before that, yes. Okay, we have marked that question answer. The major organic product in the reaction. In the reaction, this is secondary. This is not tertiary. This is not tertiary. So reaction goes via SN2 mechanism. And when SN2 mechanism takes place, you have to break oxygen in smaller alkyl group. Give iodine to this and give H to this. Give iodine to this, give H to this. Now, tell me, is this point clear? So it will be CH3I and another will be alcohol. CH3I, another will be alcohol. CH3I is only this one. That means another will be alcohol. So this will be the product. But if HI is taken in excess, then this alcohol is also converted to alkyl iodide. I hope this point is clear. Then, incorrect method to synthesize benzaldehyde. Incorrect method. You have to tell me incorrect method. Have a look. Cyanide on treatment with methyl magnesium bromide. This is benzonitrile. I mean, say cyanide. This is benzonitrile. This on treatment with methyl magnesium bromide. Now, what will happen? It will attack to this and this bond will be broken. So, it will result in the formation of first this one. This upon hydrolysis results in the formation of ketone. So here ketone will be obtained. Benzaldehyde will not be obtained. This reaction is Rosenmund reduction. Replace Cl by H. That means benzaldehyde will be obtained. This reaction is convert ester to CHO group by using diol H, diisobutyl aluminium hydride. That means benzaldehyde can be obtained during this reaction. This is Itard's reaction. It converts CH3 to what we call CHO. That means here benzaldehyde is obtained, benzaldehyde is obtained, benzaldehyde is obtained. But here it is acetophenone, which means benzaldehyde is not obtained in this reaction. So you have to choose incorrect method to synthesize benzaldehyde. That means it is incorrect method. With the help of this method, we cannot obtain benzaldehyde. After this, the intermediate compound X in the following chemical reaction is, you have to tell me what is this X. Have a look. Have a look. Whenever, this is Itard's reaction basically, whenever you are having toluene, and this toluene on treatment with CrO2Cl2, I mean say chromyl chloride, NCS2, results in the formation of an intermediate, and that intermediate is this one. It is OCrCl2OH and then OCrCl2OH, and this is a brown chromium complex. Brown chromium complex is obtained. Brown chromium complex is obtained, dear students. So, what is this? This is what we call X. According to the question, which is this? It's OCrOHCl2 whole 2. That means it is this one. It is this one. So, this is our X. And this whole reaction from which we get benzaldehyde from toluene by using chromyl chloride followed by hydrolysis is known as what we call Itard's reaction. Itard's reaction. I hope this point is clear. After this, identify compound X in the following sequence of reactions. You have to identify X. Have a look. First, it is chlorination, benzylic chlorination, side chain halogenation, free radical substitution reaction. Followed by hydrolysis gives benzaldehyde. That means here, it's a controlled chlorination. It results in the formation of, have a look, benzyl dichloride. It first results in the formation of, this is actually like this. It is actually like this. It is controlled halogenation or controlled side chain halogenation. It is CHCl2 actually. This upon hydrolysis gives this. That means our X is this one. Our X is this one. Benzyl dichloride. Benzyl dichloride is our X. That means our X is this one. Is this clear, beta? Is this clear? Let me know quickly. Let me know quickly in the chats. Is this point clear? Is this point clear? Everyone, everyone, come on, quick. Is this point clear? Okay, that's great. That is great. That is great. That is great. Now, after this, question says, identify the compound in the following reaction. Is this reaction clear to you? Is this clear reaction visible to you? Let me check whether the reaction is visible to each and every one or not. Yes, it is visible. Now, this reaction is Rosenmund's reduction. This is Rosenmund's reduction. That means our starting compound should be benzoyl chloride. Our starting compound should be benzoyl chloride, because benzoyl chloride means this one. It is benzoyl chloride. It is COCl. And what has happened during this reaction? The Cl will be replaced by H and we will get benzaldehyde. So this is Rosenmund's reduction. This is Rosenmund's reduction. Now, once again, this is Rosenmund's reduction. Here, Cl will be replaced by H. That means we will get aldehyde. We will get RC double bond OH. That means we will get aldehyde. Once again, a Rosenmund's reduction is asked. Now, after that, which of the following can be oxidized to corresponding carbonyl compound? Corresponding carbonyl compound. Which of the following is oxidized to carbonyl compound? Have a look. What is first one? First one is 2-hydroxypropane. That means it's a secondary alcohol. Which is, what is third one? Third one is 2-methyl, and then propan-2-ol. This is a tertiary alcohol. Then it is phenol, then it is phenol, then it is phenol, then it is ethanol, then it is ethanol. Have a look. We know ethanol results in the formation of, carboxylic acid upon treatment with strong oxidizing agent. It will result in the formation of ketone, and it does not react at all. It results in the formation of benzoquinone. Now, if we use mild oxidizing agent, it will give aldehyde. Ethanol will give aldehyde. This will give, ketone, but these will not react at all. In nutshell, which of the following can be oxidized to corresponding carbonyl compound? Corresponding carbonyl compound. It can be, but if this, oxidation takes place by using strong oxidizing agent, then most appropriate answer is 2-hydroxypropane, because it results in the formation of ketone, which is a carbonyl compound, but it results in the formation of carboxylic acid. It will not react. It will form dicarbonyl compound, that means benzoquinone. That's why we prefer this one. This is most appropriate answer. Now, reaction by which benzaldehyde cannot be obtained. Benzaldehyde cannot be obtained with the help of which reaction? Have a look. First reaction is Rosenmund reduction. Just replace Cl by H. Benzaldehyde is obtained. Then this is Gattermann, what we call Koch reaction, and we get benzaldehyde over here as well. This is the reaction which this zinc amalgam cannot react with COH at all. This is what we call Itard reaction. This can also form benzaldehyde. So we will simply say this is the reaction where benzaldehyde cannot be obtained. Okay. After that, dear students, have a look. The catalyst used in Rosenmund's reduction is palladium barium sulfate. It is palladium barium sulfate. Very, very, very simple. That means it is clear. It's clear from these reactions that Rosenmund reduction is the reaction which is most repeatedly asked. I hope this point is clear to you. After that, identify the final compound D. You have to identify the final compound. But what is the reaction? Reaction is like this. CH3CHO. Upon treatment with lithium aluminium hydride followed by hydrolysis, what will be the product? Simple. Just break this bond, add H and H to this. That means we will get alcohol. We will get alcohol like this. So this is A. This A on treatment with H2SO4 followed by, heating. That means this is actually dehydration. So it is intermolecular dehydration resulting in the formation of ethene. Intramolecular dehydration. So this is B. This is B. This B on treatment with HBr, electrophilic addition reaction, finally it will result in the formation of CH3CH2Br. This is C. This C on treatment with aryl halide. So alkyl aryl halide reacts with sodium in dry ether. Whenever alkyl halide and aryl halide reacts with sodium, this is known as Wurtz-Fittig reaction. This is known as Wurtz-Fittig reaction, and major product is aryl and alkyl part combined together to form alkyl benzene. I hope this point is clear. So it is ethyl benzene which is obtained as, this is what we call D. So we have to tell me what is D in the following reaction. Yes, D. So this is D. So this is D. It is ethyl benzene. It is ethyl benzene. After that, identify the major product obtained in the following reaction. This is aldehydic part, that is ketonic part, and this twice AgNH3 whole 2 positive OH minus means it is Tollens reagent. And we know Tollens reagent oxidizes aldehyde. It does not, oxidize ketone at all. That means ketonic part remains as such. This CHO has been oxidized to COO minus. That means it's option C, which is the correct answer. It's option C, which is correct answer. Ketone remains as such, but aldehyde is oxidized to COO minus. After that, identify the product in the following reaction. This is basically ketonic part. This is ketonic part, zinc amalgam, HCl, means Clemmensen reduction. What will be the product A? Sorry. What will be the product A? C double bond O is converted to CH2. This C double bond O is converted to CH2. So, it will be option number 1. It will be option number 1. It is C double bond O converted to CH2. This C double bond O is converted to CH2. I hope this point is clear to you. I hope this point is clear to you. This is normal Clemmensen reduction reaction. Complete the following reaction. This is cyanohydrin formation. This is nucleophilic addition reaction. Yes. After that, once this cyanohydrin is formed, it is C triple bond N. This on treatment with concentrated H2SO4. This on treatment with concentrated H2SO4. What will happen? Here, solvent is also water. It will hydrolyze in presence of acid. It becomes COH, and this will result in the formation of a carbocation first, and finally it will form a double bond. So the product will be like this. It forms COH and it will result in the formation of a double bond. Why? Because this OH reacts with acid, becomes OH2 positive. That will leave a carbocation will be formed over here to adjacent. Carbocation is this. From adjacent position, it will be hydrogen which will be lost. So it will result in the formation of this one. Very, very simple reaction. Very, very simple reaction. After that, it is like this. Have a look. It is pH. Which on treatment with HBr first results in the formation of this product. First results in the formation of this. This on treatment with magnesium, dry ether. What is the function of magnesium? Whenever there is CX bond, magnesium comes in between C and X. That means it results in the formation of this Grignard's reagent. This is positive part. This is negative part. Now, this on treatment with carbon dioxide and followed by hydrolysis. Listen carefully. This negative part will react with this and form a carboxylic acid. That means it will form pH, and then here it will be COOH. That means it forms a carboxylic acid. So this is A. This A on treatment with SOCl2. This OH will be replaced by Cl. OH will be replaced by Cl. So it will form Cl like this. Then finally, it reacts with CH3NH2. Now, it will attack this, Cl will be lost. Cl and H will be lost. That means instead of this Cl, it will be NHCH3. So it will result in the formation of this C double bond O, then it is NHCH3. So pH, C, first of all, this is A and this is B. You have to tell me first A. A is this one. A is this one. That means it is COH over here. It is PHCCH3, PHCCH3 and COH. So it is A. It is A. It is A. This is A. If this is A, what about B? Is B that one? PHCCH3, PHCCH3, then CONHCH3, then CONHCH3. So it is option number C. I hope this point is clear. I hope this point is clear. Match list 1 with list 2. You have to match 1 with list. You have to match list 1 with list 2. You have to match list 1 with list 2. Now, list 1 is products formed. List 2 is reaction of carbonyl compound with. That means if carbonyl compound reacts with NH2OH, carbonyl compounds react with hydroxylamine. Do you know what will be the product? Have a look. When carbonyl compound reacts with hydroxylamine, have a look, have a look, have a look. Water will be lost. What will be the product? Oxime, C double bond NOH. This will be the product. This will be the product. That means this one will form oxime. That means D1. That means D is 1. After that, carbonyl compound on treatment with. Carbonyl compound on treatment with. What? This one. H2NR. That means primary amine. Water will be lost. It will form substituted imine, alkylated imine known as Schiff's base. Known as Schiff's base. This was oxime. This is Schiff's base. That means this second and Schiff's base. That means C. C is second. C and second. C and second. Okay. After that, carbonyl compound with alcohol. Carbonyl compound with alcohol. Simple type of reaction like this. It results in the formation of acetal, acetal if it is aldehyde, or ketal if it is ketone, acetal. That means third B. That means B is third. Okay. Then HCN with HCN, with HCN, with HCN, it forms cyanohydrin. It forms cyanohydrin. That means it forms cyanohydrin. That means it is A, which has been formed from 4. This reaction is nucleophilic addition followed by elimination of water. This is nucleophilic addition followed by elimination of water molecule. This is nucleophilic addition reaction. This is also nucleophilic addition reaction. Now, have a look. D1, C2. D1, C2. That means A4. Let me write down this one. A4. That means this one. A4, B3, B3, C2, C2, D1, D1, like this. I hope this point is clear. I hope this point is clear, beta. Now, a very, very, very important question. And question says, which one of the following is not formed? Which one of the following is not formed when acetone? What is acetone? Acetone means this one. Acetone means this one. When acetone and pentan 2-on is this one. 1, 2, 3, 4 and 5. Okay. In presence of dilute NaOH followed by heating, that means which one of the following is not formed during aldol condensation of these? And this is different carbonyl compound, that means cross aldol condensation. How to check? Cross aldol condensation product is given. You have to check. I mean to say, you have to check which one is not formed. So this is known as simple retro. How to check? Have a look. Just try to break carbon-carbon double bond. Try to break carbon-carbon double bond, because carbon-carbon double bond will be formed during condensation. Break carbon-carbon double bond. There will be two parts. One part will be without oxygen. Another part will be with double bond O. That part which is without, oxygen, give oxygen to that and give 2 hydrogen to another part. That means this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is known as pentan 3-on. This is pentan 3-on. And this is 1, 2, 3, 4, 5. This is also pentan 3-on. But pentan 3-on is not the reactant. That means this can never be formed from these two. Acha, what about this one? If you break this, give 2 hydrogens to this, because this part contains oxygen, and give oxygen to this, but double bond oxygen. So it is CH3, C double bond O. Then CH2, CH2, CH3. So 1, 2, 3, 4, 5. So it is pentan 2-on and this is acetone. One is pentan 2-on, another is acetone. So these can combine and form this one. Now break this bond, give double bond O to this and give hydrogens to this. This is 1, 2, 3, 4, 5. This is pentan 2-on and this is acetone. That means both can form this. If you break this bond, give oxygen to this, double bond oxygen to this, give hydrogens to this. That means it is acetone and acetone. That means acetone and acetone can combine together to form this. That means this can be formed, this can be formed, this can be formed, but this cannot be formed. So the question is, which one of the following is not formed? So option first is not formed during cross-aldol condensation between these two. I hope this is clear, because there will be only 4 products. One is formed, this and similar type of this, that means self-aldol, another this and similar type of this, self-aldol, another 2 hydrogen from this, oxygen from this, another 2 hydrogen from alpha position and oxygen from this. That means 4 products can be formed. This can never be formed. This product can never be formed. I hope this point is clear. Let me know quickly, is this point clear? Because this is a very, very important reaction known as retro-aldol condensation or retro-cross-aldol condensation. Is this point clear? Is this point clear? Everyone, let me know in the chats quick. Is this point clear? Is this point clear, beta? Come on, everyone. Come on, everyone. Come on, everyone. Quick, without wasting time. Come on. Yes, very good. Very good. Nice. At the rate of Anurag, thank you. At the rate of Sri, thank you. At the rate of Nostalgic Universe, great. At the rate of Kanawan, at the rate of Shyam, at the rate of Rohit, great. At the rate of Akshay Kumar, at the rate of Yuvraj, at the rate of Nandish, great beta. At the rate of the G-Man, at the rate of NTT. Come on, everyone. Okay, now, next reaction. Next question says, this is the compound. Have a look. This is the compound. Very simple. But you have to check from which topic most of the questions have been repeated, because it will help you in your NEET 2026, because it's going to help you if you try to remember from which portion major questions have been asked. Have a look. This part is ester part. This is ester. This upon treatment with NaBH4 followed by, say ethanol, that means it is reduction. But NaBH4 cannot reduce ester. That means ester remains as such, but it can reduce this part, ketone, and this bond is broken. Add H to this, add H to this. That means it will result in the formation of C single bond OH here, but it will remain as such. That means, my dear lovely students, this is O here. It is OH here, OH here, OH here. That means it can never be this one, C, because C double bond O has been converted into alcohol. But ester remains as such. Here, it's not, say ester here is reduced. Ester here has been converted into something else. Say it is this one. Ketone gets converted to alcohol, but ester remains as such. Ester remains as such. Why? Because NaBH4 cannot reduce ester. That means our product is actually like this. This has become C single bond OH. This CH3 remains as such. CH2, CO, O, CH3 remains as such. Have a look. This is similar to that of 1. So option number 1 is the right answer. After that, reaction between acetone and methyl magnesium iodide. That means this one. Acetone is this. Then it is methyl magnesium iodide. It is like this. Listen carefully, because these sort of sessions are very much helpful, but for only those students who have a good hold on reaction part, who have a good hold on organic chemistry, because others can not, do these types of questions. Now, what will happen? Have a look. It is this methyl which will attack this. So this is normal nucleophilic addition first. So it is normal addition product will be obtained. Normal addition product will be obtained over here. This is negative, positive. This is CH3. This is also CH3. Now, this upon hydrolysis results in the formation of this bond is converted to OH. So it results in the formation of tertiary alcohol known as tertiary butyl alcohol. Plus this MgI is there and this O becomes OH. So hydroxy magnesium iodide and tertiary butyl alcohol. So it is this one, tertiary butyl alcohol. Tertiary butyl alcohol is the right answer. After that, reaction between benzaldehyde and acetophenone. Have a look. This is benzaldehyde. This is benzaldehyde. This is acetophenone. This is acetophenone. These are different, I mean say carbonyl compounds in presence of NaOH, dilute NaOH. That means in presence of base. What will happen? This is having alpha hydrogen, this is not having alpha hydrogen. So it is cross aldol condensation because this reaction takes place even at low temperature. Why? What is the driving force? Why it undergoes cross aldol condensation? Why not cross aldol reaction? Why alpha beta unsaturated compound is obtained? Because by doing so, this pi bond and this ring shows extensive conjugation, extended conjugation. I mean say conjugation is extended here because of these rings. So that's why it is very much stable. So that's why once I mean to say here aldol reaction product is formed, it undergoes dehydration very fast to form alpha beta unsaturated product. So this type of reaction is known as cross aldol condensation. Cross aldol condensation because this is the condensation product and these are what we call different aldehydes which can show this reaction. So it's cross aldol condensation. Cross aldol condensation. Then reaction is like this. You are having X which is C2H6O. This on treatment with copper at a temperature of 573 Kelvin gives A, which on treatment with Tollens reagent, I mean to say, gives silver mirror test. Let me write down like this. It gives silver mirror test. That means Tollens reagent shows, I mean say on treatment with Tollens reagent, it shows silver mirror test. That means this is obviously aldehyde. This can never be a ketone because ketones do not show silver mirror test. After that, this is aldehyde. This aldehyde upon treatment with this, that means aldol condensation. That means this aldehyde should contain alpha hydrogen. It should contain alpha hydrogen because on this, it will result in the formation of Y, that means aldol condensation. And after that, it's treated with NH2, NHCO, NH2, and it results in the formation of this Z. Say for example, this is Z. Now, this will be semicarbazide. This will be semicarbazide because this is semicarbazone. So it will be a semicarbazide. Now, this is aldehyde. But aldehyde is formed from which alcohol on treatment with this primary alcohol? Primary alcohol having two carbons. It is CH3CH2OH actually. So X is ethanol. If it is ethanol, this is ethanol, that means CH3CHO. If it is ethanol, then this is CH3CH double bond, I mean say CHCHO. That means it is 1, 2, 3, 4. It is but-2-enol or but-2-enol. Okay. So let me tell you that X is ethanol. X is ethanol. That means either this or this. These can never be the products. Okay. But A is ethanol. A is ethanol. That means it is this one. A ethanol, X ethanol, Y but-2-enol. Yes. And Z is semicarbazide. Yes. Clear. It is this one. It is this one. This reaction is known as simply aldol condensation, self-intermolecular or simple intermolecular aldol condensation. I hope this point is clear. Tollens reagent will oxidize this CH3CHO2, CH3COO-. I hope this point is clear. Of the following, which is the product formed when cyclohexanone? Cyclohexanone is this one. when it undergoes aldol condensation, that means there is no other carbonyl compound given. So you can write down this carbonyl compound once again. Write down the same carbonyl compound once again, but in this fashion, so that you can show 2 alpha hydrogens and this oxygen. It will undergo aldol condensation. So the product of this reaction will be simply, here there will be a double bond between 2 6-membered rings, and that double bond will be present at alpha and beta position with respect to C double bond O. So which is the product which has been formed during this reaction? It is A. Very, very simple. So this is the simple or self intermolecular aldol condensation product of cyclohexanone. I hope this point is clear. The product formed by the reaction of aldehyde with the primary amine. A reaction of aldehyde, that is this one, with primary amine. Primary amine is this one. It results in the formation of imine. It results in the formation of imine, and this is alkylated imine known as Schiff's base. So aldehydes are ketones. On treatment with primary amine results in the formation of Schiff's base. Okay. Then an organic compound X having molecular formula C5H2, my goodness, what is this? It is C5H10O. It is C5H10O. Let me erase this. It is C5H10O. Okay, this is the question. So we are having a compound X, that means X compound is there whose formula is C5H10O. Okay, this gives phenylhydrazone. It gives phenylhydrazone. That means it gives this one. Okay, and negative response to iodoform test and Tollens test. So X gives phenylhydrazone, and X on treatment with I2NaOH, no reaction, will not form, negative, I will not form, no iodoform is formed. No iodoform is obtained. That means it gives negative test. Okay. It gives negative test to Tollens. It also gives negative Tollens test. That means upon treatment with Tollens reagent, no silver mirror is obtained. So this is the question. It produces N-pentane on reduction. On reduction, it obtains N-pentane. Now, first of all, it results in the formation of this. That clearly indicates that this is either aldehyde or ketone. With the help of this, it can be aldehyde or ketone. But it does not form silver mirror test. That means it is not an aldehyde now, because if it is aldehyde, it forms silver mirror test. Now, it does not form, iodoform. That means this is ketone, but not methyl ketone. It is not this type of ketone. It can never be this type of ketone. If it is not this type of ketone, then upon reduction, ketone upon reduction forms pentane. You have to tell me which type of ketone is this. Is this, say this one or this one. These two can never be the product, because it is ketone now. Now you have to check whether A or B. Have a look. A ketone is this. 1, 2, 3, 4, 5, 2 pentan 2 on or 2 pentan on. Second ketone is this. So these two, among these two, X is either A or B. Now the question is, can X be A? Answer is no. It cannot be X. Why? It cannot be X. Why? Because it shows iodoform test. It shows iodoform test. It shows iodoform test. That means it will give positive iodoform test. It will not give positive iodoform test. That means it is this one. That means it is this one. So X is this one. X is that one. 3-pentanone. I hope this point is clear to you. I hope this point is clear to you. Come on, my dear lovely students. Is this point clear to you? Let me know in the chats. Is this point clear to you? First of all, it forms phenyl hydrazone. That means if it forms phenyl hydrazone, so it clearly indicates that it has been reacted. That X reacts with what we call, it reacts with simply what we call phenyl hydrazine, so that it forms phenyl hydrazone. But it can react, aldehyde or ketone can react with phenyl hydrazine to form this one. That means with the help of the formation of phenyl hydrazone, it is clear that X is either aldehyde or ketone. But it does not react with Tolan's reagent. That means it can never be an aldehyde. So it can be a ketone. Now the question is, it does not form iodoform test. That means it can never be this type of ketone. Yes or no? But we are having only two types of ketones. So if it cannot be this, then it is this one. I hope this point is clear. I hope this point is clear. Let me know quickly, is this clear to each and every one? After that, we will be having another reaction. The treatment of cyclopentanone. Cyclopentanone is this. Cyclopentanone is this. Treatment of cyclopentanone with zinc amalgam. That means it is this one. In acidic medium, obviously, gives the following species. This is known as Clemmensen reduction. This is simply Clemmensen reduction. And we know Clemmensen reduction converts C double bond O into CH2. So cyclopentanone, this is cyclopentanone. Cyclopentanone will form cyclopentane, will form cyclopentane, will form cyclopentane, will form cyclopentane. I hope this point is clear. I hope this point is clear. I hope this point is clear. I hope this point is clear, beta. Now, which of the following is more reactive towards nucleophilic addition? Remember, nucleophilic addition reaction is shown by those carbonyl compounds which are having most electron deficient carbonyl carbon. That means those carbonyl compound in which this C double bond O carbon is most electron deficient. That means if it is attached to electron withdrawing group, nucleophilic addition rate will be very much fast. But first of all, this is aldehyde, 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 ketone. Among aldehydes and ketones, it's always aldehyde which shows faster nucleophilic addition reaction. So leave it. This is aldehyde, aldehyde, aldehyde. This aldehyde is having benzene ring. This is having benzene ring as well as methyl group, electron donating. But this is having electron withdrawing group. Electron withdrawing group increases nucleophilic addition reaction of aldehyde or carbonyl compound. So this is the most reactive. This is most reactive. After that, it will be A. After that, it will be C. B will be at last. I hope this point is clear. After that, predict the product in the given reaction. Predict the product in the given reaction. Have a look. This is aldehyde without acidic hydrogen or without alpha hydrogen. This on treatment with 50% KOH means it's a Kenny-Zorro's reaction. Kenny-Zorro's reaction means one molecule of this aldehyde is oxidized to COOK because it's K. If it is Na, then CONA. Similarly, another is reduced to CH2OH, that means alcohol. That means one is alcohol, another is COO negative. But this is CH2. No, number of carbons are more here. So it is like this. It is this one. These two are at meta positions with respect to each other. One CH2OH and another is converted to CO minus. That means one is reduced, another is oxidized. It is simple oxidation reduction reaction. This is known as Kenny-Zorro's reaction. But this is only having only one type of aldehyde is there. So this is what we call simple or self-intermolecular Kenny-Zorro reaction. After that, CH3CHO, CH3CHO and C6H5CH2CHO. Have a look. This is CH3CHO. That means this is an aldehyde. Another is this one. This is also an aldehyde. But sometimes we get confused. We think this is aromatic aldehyde. No, answer is no. Aromatic aldehyde means in which CHO is directly attached to, say, aromatic ring. So this is not aromatic aldehyde. I hope this point is clear to you. So this is once again an aliphatic aldehyde in which hydrogen has been replaced by aromatic compound. I hope this is clear. This is aryl substituted aliphatic what we call aldehyde. So neither of them is aromatic aldehyde. If neither of them is aromatic aldehyde, have a look. We can distinguish them with the help of iodoform test. This shows iodoform test, but this does not show. Yes, we can distinguish them by means of iodoform test. Tollens test, no. Why? Because this can show tollens test, this can show tollens test. After that, Fehling solution test. Fehling solution test is shown by, Fehling solution test is shown by only aliphatic aldehydes, and both are aliphatic aldehydes. That means this can show Fehling's test. After that, it is Schiff's test. It is Schiff's test. Schiff's test is shown by, say aldehydes only. Ketones will not show this test. That means Schiff's test is also shown by both. So all these three tests are shown by both, but iodoform test is shown only by this. That's why we can distinguish these two with the help of iodoform test. After that, what sort of reaction is it? Aldehyde plus what we call hydrazine gives hydrazone plus water. It is simply nucleophilic addition followed by elimination of water. That means it is nucleophilic addition and then elimination. Nucleophilic addition and then elimination. Which of the following compounds will give a positive iodoform test? First one is acetophenone. Have a look. Acetophenone is this one. Then methyl acetate. Methyl acetate is this one. Then 2-hydroxypropane. 2-hydroxypropane is this one. And then glucose. Glucose. Now, iodoform test is given by aldehydes or ketones having C double bond O. This is, say ester, it will not show. This is aldehyde, but it does not having C double bond O CH3 group. C double bond O CH3 group is not present. That means it will not show. But iodoform test is also shown. Iodoform test is shown by aldehydes or ketones having C double bond O group. But in addition to that, iodoform test is also shown by alcohols having this group. That means this can show, but this and this cannot show. That means here are two options, correct options. One is A, another is C. One is A, another is C. But it is not actual name. 2-hydroxypropane is not the actual name. It's basically propan-2-ol or 2-propanol. Is this point clear to you? Is this point clear to you? Not only A, because it's not which compound, it's not written which say aldehyde or ketone or alcohol shows. Its question is which of the following compounds give positive iodoform test. Positive iodoform test is shown by those compounds in which this group is present, if that is aldehyde or ketone. This is for aldehydes and ketones. For aldehydes and ketones, it is this one. And for alcohols, it is this one. This is for alcohols. So have a look. This is alcohol and it's having CH3CHOH group. This is ketone, it's having CH3CO group. So both can show, say iodoform test. Both can show iodoform test. After this, reduction of ketones is carried out in presence of which of the following? Reduction of ketones is carried out which of the following? Now tell me. Reduction of ketone by using lithium aluminium hydride. Reduction of ketone takes place by using lithium aluminium hydride, because reduction of ketone gives alcohol. So among these, it's lithium aluminium hydride, and it will result in the formation of this one. Break pi bond, give H and H to this, so it will give alcohol. It can be sodium borohydride, it can be H2 in presence of catalyst, it can be sodium in alcohol, but here other options are not present, so it is simply lithium aluminium hydride. I hope this point is clear. Or it can be H2 and PD, not BaSO4 catalyst. Okay. After this, the order of reactivity of phenyl magnesium bromide with the following compound. Phenyl magnesium bromide is this one. Phenyl magnesium bromide is this one. And when they react, when phenyl magnesium bromide reacts with aldehydes and ketones, it's simply nucleophilic addition reaction. You have to tell me which compound can form nucleophilic addition reaction very fast. We can show nucleophilic addition reaction very fast. It's aldehyde, after that ketone. But among ketones, it is obviously this aliphatic ketone, after that this aromatic ketone. So it is simply one aldehyde first, and then this aliphatic ketone, and then aromatic ketone. That means it's 1, 2, and 3. Very, very simple. 1, 2, and 3. After that, which of the following compounds will be most readily dehydrated? That OH group will be most easily dehydrated, which forms most stable carbocation. Have a look. If this is broken after dehydration, because it reacts with H positive with acid, it will be lost as OH2 positive, then finally carbocation is formed over here. But this group is an electron withdrawing group. Similarly, this will be broken, carbocation will be formed. This is an electron withdrawing group. This will be broken, carbocation will be formed. This is electron withdrawing group. So in all these carbocations, electron withdrawing group is directly attached to the carbocation and makes it this carbocation and this carbocation very unstable, less stable. But if this is lost, this is an electron withdrawing group, and what we call distance between electron withdrawing group and carbocation is more over here. That means here positive charge is not that much unstable as it is present in C, B, or A. That means in comparison to others, this carbocation is more stable as compared to A, B, and C. Hence, this will undergo dehydration easily as compared to A, B, and C. I hope this point is clear. So, dehydration of alcohol is directly proportional to stability of carbocation formed during that reaction in RDS. Okay. Now, reduction of aldehydes and ketones into hydrocarbons using zinc amalgam and concentrated HCl is called simple reaction. This is known as Clemmensen reduction. If reduction of aldehyde and ketone to hydrocarbon takes place in presence of hydrazine in basic medium, then that is known as Wolff-Kishner reduction. You know that. This reaction is known as what we call Clemmensen reduction. This is Clemmensen reduction. After that, a carbonyl compound reacts with hydrogen cyanide. Carbonyl compound reacts with hydrogen cyanide. A normal nucleophilic addition reaction, and we get a cyanohydrin. Now, which on hydrolysis forms, have a look, which on hydrolysis forms this one. Now, it shows, question gives, which on hydrolysis forms a racemic mixture. And racemic mixture is formed only if this is the chiral center. If this is the chiral center, at that time, we get enantiomers. We get this and mirror image of it in equal proportions. When we get mirror images, enantiomers in equal proportions, mixture is known as racemic mixture. So, you have to find out the carbonyl compound is. This carbonyl compound is, can it be acetone, CH3, same, CH3, no, because this should be what we call chiral center. But if I write CH3 here, in case of acetone, it will be CH3 and CH3. So CH3 and CH3, CH3 and CH3. At that time, this will not be a chiral center. What about this diethyl ketone? Diethyl means ethyl and ethyl. Similar groups are on same sides, both sides. Then it will also not form a chiral center. To form racemic mixture, it should be chiral center. Formaldehyde, that means H and H, no. Then acetaldehyde. Acetaldehyde means this one, CH3 and H. That means it will be CH3 and H. That means here it will be CH3, it will be H. Have a look. This is sp3 hybridized center, and to this center 4 different groups are attached. So one will be this product which is formed, plus its enantiomer will also be obtained. and both will be obtained in equal proportions. That means we will get what we call racemic mixture. We will get racemic mixture. So racemic mixture is obtained only from this aldehyde during this reaction. I hope this point is clear. I hope this point is clear. Everyone, beta, everyone, is this point clear? At the rate of Yuvraj is saying B. No, beta, it's not B. It's not B. It is D. It is D. Because B means diethyl ketone, means ethyl and ethyl are present here. If ethyl and ethyl are present, there will be no chiral center. No chiral center, that means there will be no enantiomer for that. I hope this point is clear. I hope this point is clear. After this, which one of the following esters gets hydrolyzed most easily under alkaline conditions? Under alkaline conditions. Remember that ester undergoes hydrolysis easily because it is nucleophilic acyl substitution. That ester will undergo what we call hydrolysis easily, in which electron withdrawing group is there. Why? Have a look. Have a look. Have a look. This is N double bond O and O, negative, positive. Say for example, it's like this. And you are having O, C double bond O, single bond CH3. Have a look, beta. Have a look. What will this NO2 do? It will withdraw electrons. It will withdraw electrons, withdraw electrons. That means when it withdraws electrons, finally it will form a structure like this, in which this oxygen becomes positively charged. So because of this electron withdrawing nature, oxygen becomes positive charge. Once oxygen becomes positive charge, it withdraws electrons and this becomes electron deficient. So when this becomes electron deficient, attack of water in a nucleophilic attack will be very, very, very easy. That means hydrolysis, for hydrolysis of ester, remember hydrolysis or nucleophilic acyl substitution in case of ester increases if ester contains electron withdrawing group, and electron withdrawing group is strong in A. That's why it is option number 1. I hope this point is clear. I hope this point is clear. After that, match the compounds given in list 1 with list 2 and select the suitable option using the code below. Number 1, benzaldehyde. Benzaldehyde. Number 2, phthalic anhydride. Number 3, phenyl benzoate. Number 4, methyl salicylate. These are the compounds in list 1. Phenolphthalein, benzoin condensation, oil of wintergreen, Fry's rearrangement. These are list 2 compounds. Have a look. Benzaldehyde upon self-oxidation. Sorry, upon self-condensation, not oxidation. Upon self-condensation in presence of KCN, what will happen over here? This H, this bond will be broken. C becomes C positive and O becomes O negative. O negative will abstract this H and C goes to this. This is a trick. This is not the mechanism. This is the trick. Now, I mean to say it becomes CH and this double bond O becomes single bond OH. And then this carbon forms bond with this. This is known as benzoin and the reaction is known as benzoin condensation. That means benzaldehyde shows benzoin condensation. So A2 means it's only this one. It's only this one. Only this one. It's actually this is A, this is B, this is C and this is D. So A2 means this and this. C and D can be the answer. After that, phthalic anhydride. Phthalic anhydride is this one. Phthalic anhydride is this one. It reacts with phenol and forms phenolphthalein. That means phthalic anhydride. B is 1. B is 1. A is 2. B is 1. That means option D is the right answer. Then phenyl benzoate. Let me write down phenyl benzoate over here. Phenyl benzoate this during Fry's rearrangement, this group is migrated to ortho or para position. So it results in the formation of this one, either ortho or para. So I can write down like this. So this is known as Fry's rearrangement. So it is C which is 4. So C is 4. And lastly, it is D. Methyl salicylate is the major constituent of oil of wintergreen, also known as oil of wintergreen. That means D is what we call 3. So A2B1, A2B1, C4, C4, D3, D3. That means it is this one. D3. So option D is the right answer. Option D is the right answer. Option B is the right answer. Option D is the right answer. After this, an organic compound A on treatment with ammonia gives B, which on heating gives C. As all these are carboxylic acids, all these are carboxylic acid, we have to find out A. That means all these are carboxylic acid. Carboxylic acid on treatment with ammonia forms ammonium salt, which upon heating loses water and gives amide. That means amide will be obtained among these. So amide will be obtained first. So these upon treatment with ammonia gives B. That is basically ammonium salt of carboxylic acid. Let me write down that RCOONH4. It is like this. So this is B. B upon heating gives C. That means this is C because this is amide. Now when this C is treated with Br2, in KOH, this is Hoffman bromamide reaction. You have to remove C double bond O and we will form primary amine with one carbon lesser, produces ethyl amine. Now this will be the formation of, say this C on treatment with this produces ethyl amine, but here it is primary amine. Now if it is ethyl amine, that means value of R is CH3CH2. Now tell me beta, if R is CH3, R is CH3CH2 because it is ethyl amine. R is CH3CH2, that means this is CH3CH2. This is CH3CH2 and acid from which this has been formed is like this because it has been formed from carboxylic acid. Now what is the value of R? Put this value into this. That means CH3CH2 COH, CH3CH2 COH. It is propanoic acid. CH3CH2 COH, it is propanoic acid. That means propanoic acid upon treatment with ammonia forms this one first, then this, then finally it will result in the formation of ethylamine. I hope this point is clear. I hope this point is clear. I hope beta this point is clear. I hope this point is clear. Let me know quickly beta. Let me know quickly in the chats because this is very, very simple but very, very important reaction. Hoffman bromamide reaction is this. Okay, thank you very much. After this, in a set of reaction, ethyl benzene yielded a product D. First, ethyl benzene. On treatment with KMNO4, KOH, it actually gives COOK. Now, this COOK on treatment with Br2, FeBr3, as this is electron withdrawing, this is meta directing group C double bond O minus. Now, it will result in the formation of COOK and to its meta, it will be Br. It's electrophilic substitution, bromination taking place at meta position. Now, this on treatment with, as in acidic medium, reaction takes place. That means it becomes first COH, that means it's acid and alcohol. It is normal, what we call esterification reaction. So it will result in the formation of COOC2H5. And then to para position of that, it is Br. That means one group is ester, another is Br, but both are at para position with respect to each other. Or you can simply say, you can simply say this salt of carboxylic acid has been formed, which upon acidification gives first acid, then that acid on treatment with alcohol in presence of protonic acid gives ester. In nutshell, it is ester and bromine which are present at para position to this benzene ring. I hope this point is also clear to you. After that, beta, among the given compounds most susceptible to nucleophilic attack at the carbonyl group is most susceptible to the nucleophilic attack. Have a look. First one is CH3, C double bond O, and then O, then CH3. Then CH3CONH2. These are acid derivatives. This is ester, this is amide, this is anhydride, this is acid anhydride, and last one is acyl chloride or acetyl chloride, means acid chloride. Now, when nucleophilic attack takes place, among these, the nucleophile will attack to this position, similarly to this position, and to this position, because this is nucleophilic acyl substitution. That means in first case, this will be the leaving group. In second case, this will be the leaving group. In third case, leaving group will be this one. In fourth case, leaving group will be this one. That reaction will be, fast reaction in which leaving group is a better leaving group. Now, how to check which leaving group is better leaving group? These are leaving groups. We should know that leaving group ability, that means that group is a stronger leaving group or a very good leaving group, which is a conjugate base of what we call strong acid. That means that conjugate base, that leaving group should be a weaker base. For example, if I form, this is A, say for example, this is A, this is B, this is C, this is D. If I form conjugate acid of this leaving group, what will be the conjugate acid of this leaving group? It will be, let me write down this with the help of another pen, another color. This is like this, alcohol. What is the, acid of this? It is ammonia. What is the acid of this? It is carboxylic acid, CH3COOH. And what is the acid of this? It will be HCl. HCl is inorganic acid. Remember, it is HCl, which is stronger acid, then acetic acid, then it is, alcohol, and at the end it is ammonia. And stronger acid is having weaker conjugate base, means this is the better leaving group, because weaker acids are always very good leaving groups. So this is the better leaving group among these. So first of all, it is D, which shows nucleophilic attack very fast. After that, this is stronger acid. That means its conjugate base will be weaker base. Weaker base means among these three, this is a good leaving group. That means then it will be C. That means first acid chloride, then anhydride. After that, alcohol is stronger acid. Alcohol means this one, its conjugate base is this. That means weaker, stronger acid among these two. So stronger acid is having weaker conjugate base. Weaker conjugate base is having good leaving group. That means it's having good leaving group. So say A is having good leaving group after that. And lastly, it is B. So this is, remember, nucleophilic acyl substitution or nucleophilic substitution reaction order. Substitution order among acid derivatives. This is the nucleophilic acyl substitution order. That means first, always it will be acid chloride, then anhydride, then it will be ester, then it will be amide. Now the question is, which among following is having most susceptible to nucleophilic attack? It is obviously acid chloride. I hope this point is clear. I hope this point is clear to each and every one. Okay, that is great. That is great. Now after that, this is very, very, very important chapter. This is very, very important chapter, aldehydes, ketones and carboxylic acids. So listen. Propionic acid. This is propionic acid. Propionic acid means this one. CH3, CH2, COOH. On heating with bromine, red phosphorus, that means PBr3 will be formed and this OH will be replaced by Br. So it will form this one. Okay, sorry. It will be Hell-Wohlhardt-Zelensky reaction simply. It will be Hell-Wohlhardt-Zelensky reaction, sorry. It will not be replaced this one. It is simply alpha halogenation, alpha bromination reaction, sorry. It is alpha bromination reaction because it is bromine red phosphorus or bromine phosphorus, that means it's Hell-Wohlhardt-Zelensky reaction. It results in the formation of first one hydrogen will be replaced, then second hydrogen will be replaced. That means bromine is taken in excess because it shows a dibromo product will be obtained. That means it results in the formation of CH3, CBr and Br. Because it is halogenation which generally takes place at which position? At alpha position. So it will be like this. It will be like this because this is alpha. So it will be CH3, CBr2, COOH. I hope this point is clear. This is Hell-Wohlhardt-Zelensky reaction. After that, the relative reactivities of acyl compound towards nucleophilic substitution. Have a look. I have already given you that. Order. It is acid chloride, then anhydride, then ester. Acid chloride, anhydride, then ester. Acid chloride or acyl chloride, anhydride, then ester and then amide. It is option number 1. Acyl chloride first, then anhydride, then ester, and at the end it is amide. After this, self-condensation of 2 moles of ethyl acetate. This is ethyl acetate. Let me write down ethyl acetate in this fashion as well. Self-condensation of this in presence of sodium ethoxide. Let me write down like this. Self-condensation of esters containing at least 1 alpha hydrogen results in the formation of beta keto ester. Basically, this is an ester. In which beta position contains keto group. So this is beta keto ester. And name of this beta keto ester is ethyl acetoacetate. These are very important names for this: ethyl acetoacetate or acetoacetic ester. And this reaction is known as Claisen condensation. Not Claisen-Schmidt condensation. Claisen condensation. So the product is acetoacetic ester. It's simply acetoacetic ester. I hope this point is clear. Or it is ethyl acetoacetate, not methyl acetoacetate, ethyl acetoacetate. After that, is this slide clear to you? Or let me check. If it is clear to me on my mobile, then it will be obviously clear to you. Yes, it is clear. CH3, CH2, COH, SOCl2 on treatment with, gives B, and then it is NH3 gives C, KOH gives D. Yes, it is clear. Have a look. So it is CH3, CH2, COOH on treatment with SOCl2 gives B, which on treatment with ammonia gives C, this on treatment with KOH Br2 gives D. So you have to tell me what is D. Have a look. First of all, it is carboxylic acid on treatment with SOCl2 simply replaces this OH by Cl, CH3, CH2, COCl. Then this on treatment with ammonia, that means this is B. This on treatment with ammonia forms amide, CH3, CH2, C double bond O, NH2. So this is C. This C on treatment with KOH Br2. This reaction is very important reaction known as Hofmann bromamide reaction or Hofmann degradation reaction or Hofmann what we call rearrangement. This C double bond O will be lost and we will get CH3, CH2, NH2. So we will get this as a D. So our D is CH3, CH2, NH2 means this one, means this one. I hope this point is clear. That means this reaction is used when we want to decrease our number of carbon by 1. Because amide is having 3 carbons, this is having only 1 carbon. Because primary amine will be obtained from primary amide with 1 carbon lesser as compared to primary amide. After that, is this reaction clear? Is this reaction clear? Is next reaction clear to you? Yes, this is very much clear to you. Okay. So it is CH3COOH. It is CH3COOH on treatment with SOCl2. OH will be replaced by Cl. So it will form CH3COCl first. Now this on treatment with benzene, in presence of anhydrous AlCl3. This is normal Friedel-Crafts acylation reaction, which is electrophilic substitution reaction. These two will form, they will generate this as an electrophile. So this electrophile will attack benzene ring, and this is a normal Friedel-Crafts acylation reaction because acyl group has been introduced. And this is electrophilic substitution reaction. This on treatment with HCN forms cyanohydrin, forms beta cyanohydrin. So it will form C triple bond N and OH over here. So cyanohydrin will be obtained. This upon hydrolysis convert this CN to what we call carboxylic acid. So it will result in the formation of CCOOH because it has been, hydrolyzed to COH, and then it is OH, and then it is CH3. So phenyl ring attached to carbon, and to that carbon there are CH3COH and methyl group. So it is CH3COH phenyl, CH3COH phenyl, and OH. It is option number D. It is option number D, beta. It's option number D, beta. I hope this is clear. I hope this is clear. After that, CH3COH PCl5. CH3COOH and then PCl5. This on treatment gives CH3, C double bond OCl, obviously this is A. This on treatment with benzene, once again a same type of reaction, AlCl3, once again Friedel-Crafts acylation reaction, once again COCH3 will be introduced, COCH3 will be introduced into the ring. Then this on treatment with CH3CH2 MgBr, dry ether, what will be the reaction? This is nucleophile and it will attack this. That means normal nucleophilic addition reaction will first take place and it will result in the formation of CH2CH3. It has been added to this. Then it is O minus MgBr with a positive charge, and then finally it is CH3 over here. This upon hydrolysis will result in the formation of this product. This becomes CH2CH3. It remains as it is CH3 and it becomes OH. Or let me erase this and let me draw product over here. Let me draw product over here. This upon hydrolysis gives CH2CH3. It remains as it is. This OMGBr becomes OH. Then ring remain as it is, and this is CH3. So it is, CH3, then COH, C2H5 and C6H5. That means to carbon, it is OH, methyl, ethyl and phenyl. Carbon, OH, methyl, ethyl and phenyl. That means option 1 is the right answer. Option 1 is the right answer. Is this point clear to each and every one? Is this point clear to each and every one? Is this point clear to each and every one? Now, our next reaction will be like this. So this has been discussed. Now, next reaction. It is phenyl magnesium bromide. That means it is like this. This part is negative part, this is positive part. Remember, when it is treated with carbon dioxide followed by hydrolysis, this negative part is attached to this carbon dioxide and it will form simply COH. I mean, say this negative part and COOH, it should be like this. It is benzoic acid. Benzoic acid will be obtained. Benzoic acid will be obtained means it is this one. It is this one. I hope this point is clear. After that, benzoic acid may be converted to ethyl benzoate. This is ethyl benzoate. Reaction with sodium ethoxide, ethyl, I mean to say chloride, no, dry HCl ethanol, yes. Have a look. When it is treated with, I mean say ethanol, when it is treated with ethanol, C2H5OH, ethanol, and in presence of acid, that means dry HCl, means this one, it is simply esterification. OH from this position, H from this position will be lost. So this is simply esterification reaction and we will get COO of this and OC2H5 of this. So this can be possible. This can be possible with the help of this reaction. This is normal esterification reaction. After that, aniline. Now, these are the questions from last chapter, amines. Now, this is aniline. Aniline on treatment with CH3CO2O. This is simply what we call acetylation reaction. So it will result in the formation of this one. So H will be replaced by acetyl group. Then this on treatment with lithium aluminium hydride. Now what will happen to this? This is secondary amide. Amides upon treatment with lithium aluminium hydride, their C double bond O of amide with the help of this is converted to CH2. It is converted to CH2. So it becomes NH, then it becomes CH2, CH3. I hope this is clear. So it is like this. It is secondary amine. It is benzene, then NH, CH2, CH3. Benzene, NH, CH2, CH3. So it's very, very simple reaction. Very, very simple reaction. After that, match list 1 with list 2. This is the reaction and this is the product. Now tell me, Gabriel thalamide synthesis is having which product? Gabriel thalamide synthesis. During Gabriel thalamide synthesis, primary amine is obtained. That means it is this one. So A is 3. So let me write down over here. A is 3. A is 3 means either this one or B. These two options. Okay, now after that, coal-based synthesis. Coal-based synthesis means salicylic acid. That means B is 4. B is 4 means it's option 1. B4 means it's option 1. Now, Williamson synthesis means ether. That means C is 2. Itard reaction means benzaldehyde. That means D is 1. Yes, all the options are correct. So it is option 1. It's option A. After that, identify the compound that will react with Hinsberg's reagent to give a solid which dissolves in alkali. Remember, Hinsberg's reagent is used as a test known as Hinsberg's test, and during Hinsberg's test we use this Hinsberg's reagent when this test is used to distinguish primary amine, secondary amine, tertiary amine. That means Hinsberg's reagent cannot react with what we call tertiary amine, but it reacts with primary amine and secondary amine. Both will form solid, but primary amine, solid of primary amine is soluble in alkali and solid of secondary amine is insoluble in alkali. Now it is it is soluble in alkali, dissolves in alkali, that means it should be primary amine. It should be primary amine. Primary amine is this one. This is secondary amine, this is nitro, this is tertiary amine. So it is primary amine. After this, reaction of propanamide. Propanamide is this one. It is propanamide. With ethanolic sodium hydroxide, that means NaOH, alcoholic, and Br2. That means once again Hoffman bromamide reaction. Just remove this, you will get primary amine like this. So we will get ethyl amine in this reaction. Ethyl amine will be obtained in this reaction. I hope this point is clear. After that, which of the following amine will give carbyl amine test? Carbyl amine test is given by aliphatic as well as aromatic primary amines. That means this is the test of aromatic, this is the test of 1 degree amines. Identification test of 1 degree amines, that means it is this one. Because this is secondary amine, this is tertiary amine, this is what we call secondary amine, this is primary amine. So it can be either aliphatic or aromatic, but primary amine. So carbyl amine test is given by primary amines. Next, amine that reacts with Hensberg's reagent to give an alkali insoluble product. Now it is an alkali insoluble product. Alkali soluble product is primary amine, alkali insoluble product is secondary amine. Secondary amine, secondary amine, secondary amine. Now first one is primary amine, this is secondary amine. This is tertiary amine, no. This is primary amine, no. So only option B is the right answer. So have a look. Hensberg's test, Hoffman bromamide reaction, carbyl amine test. These are the important reactions of amines. Now, nitration of aniline in strong acidic medium also gives meta-nitroaniline because of formation of, anilinium ion. Now, okay. Options, in spite of substitution, nitro group always goes to only meta position, no. In electrophilic substitution reactions, amino group is meta direct, In strong acidic medium, aniline is present as anilinium ion. Yes, it is formed because of anilinium ion. Now, after that, which of the following reactions is appropriate for converting acetamide to methanamine? Acetamide is this one. Acetamide is this one, and methanamine is this one. What is the appropriate reagent? Have a look. This is primary amide to primary amine, but primary amine contains 1 carbon less. So this is Hoffman bromamide reaction. So you have to check which one is correct. So Hoffman, you can say Hoffman bromamide degradation, Hoffman bromamide reaction, Hoffman hypobromamide reaction. You can say Hoffman rearrangement reaction. So this is the correct one. After this, the electrolytic reduction of nitrobenzene in strongly acidic medium. Have a look, have a look, have a look. This is nitrobenzene. Upon electrolytic reduction, listen carefully. In weakly acidic medium, gives what we call aniline. But in strongly acidic medium, listen it and try to remember it. Strongly acidic medium, it first forms hydroxylamine like this. But this rearranges. Say this cannot be obtained. Once formed, it rearranges to para-aminophenol. So this is the product of the reaction. During strongly acidic medium, electrolytic reduction during strongly acidic medium is para-aminophenol. I hope this point is clear. After this, method by which aniline cannot be prepared. First one is phenyl isocyanide. Phenyl isocyanide is this one. This is phenyl isocyanide. This upon hydrolysis, listen carefully, it results in the formation of aniline and formic acid. So aniline is obtained with the help of this. Degradation of benzamide. Benzamide is this. Degradation of this by means of Hoffman bromamide. You can use NaOHBr2. You can use KOHBr2. You can use NaOBr. You can use KOBr. So this C double bond O is converted to, it is C double bond O is lost, C double bond O NH2 is converted to aniline. That means this can also prepare aniline. Reduction of nitrobenzene. Reduction of nitrobenzene by using H2 palladium. Yes, it can also convert nitrobenzene to aniline. Potassium salt of thalamide. Potassium salt of thalamide is this one. Potassium salt of thalamide is this one. Potassium salt of thalamide is this one. Okay. Treated with chlorobenzene followed by hydrolysis. Treated with chlorobenzene. Chlorobenzene is this one. Followed by hydrolysis. No, it will not form. Why? Because it is normal nucleophilic substitution which does not take place over here, because this bond is a strong bond. We know haloarenes do not show what we call substitution, nucleophilic substitution reaction under normal conditions, because this bond is strong due to partial double bond character as a result of resonance, or this nucleophile, electron cloud of this nucleophile and electron cloud of the, say this benzene ring or this phenyl ring above and below, there is electron clouds, pi electron clouds, they will repel. That means there will be no reaction. So we cannot prepare. And this reaction is, by the way, if you treat, say here, alkyl halide, reaction is known as Gabriel thalamide reaction. So during Gabriel thalamide reaction, we cannot prepare, what we call aniline. So this is the option. Method by which aniline cannot be prepared. With the help of this, aniline cannot be prepared, but all these can be used to prepare aniline, but without option number D. After this, some reactions of amines are given below. Which one is not correct? Amine, this is secondary amine. Secondary amine is aliphatic amine. Secondary amine, this is secondary, this is what we call tertiary amine. Okay, this is what we call primary amine. This is primary amine. Now have a look. Secondary amine on treatment with NaNO2HCl gives yellow oily compound nitrosoamines. That means this is correct. This is what we call a tertiary amine. Tertiary amine on treatment with NaNO2 forms diazonium salt. No. Tertiary amines, aromatic tertiary amines on treatment with this undergoes electrophilic substitution of nitro. Nitroso group will be introduced at para position, but this is not that. That means this is incorrect. This is incorrect reaction, and you have to choose a reaction which is not correct. That means this is incorrect. Primary amine, primary aliphatic amine on treatment with nitrous acid gives alcohol. Yes, this is correct. Primary amine on treatment with this gives this one. Yes, because Cl will be lost, because this will attack on this sulfur. This is nucleophilic substitution reaction. That means this is also correct. So incorrect is option B. After that, in a set of reaction, metabromobenzoic acid gave a product D. Okay, identify the product D. Have a look. This is benzoic acid. Now, first of all, is this clear? Is this clear? Yes, this is clear. Now, first of all, have a look. Have a look. It is this one. It is this one. COOH, and here it is Br. This on treatment with SOCl2. OH will be replaced by Cl. So it will result in the formation of COCl here and Br at meta position. Then NH3. So it will form amide. COCl will be converted to CONH2 and it will be Br. Finally, NaOH Br2. Once again, Hoffman bromamide step. C double bond O will be lost. C double bond O will be lost, so it will become NH2, and to this NH2, to aniline, bromine is at para position. Bromine is at para position. So it is option C. It is option C that NH2 and Br2 will be at para position with respect to each other. After that, okay, this is a secondary amine. Secondary amine on treatment with nitrous acid or NaNO2HCl gives yellow oily compound known as nitrosoamines. Gives nitrosoamine. It will give nitrosoamine. That means it's option number D. Option number D is the right answer. I mean to say, beta, whenever you are having a reaction like this, HNO2, I will write down HNO2. It came from NaNO2HCl. So it will lose water molecule and it will result in the formation of NCH3 and then it is N double bond O. So nitrosoamines will be obtained. So it is option D. Okay. After this, this is the reaction. Reaction is like this. This on treatment with H2NCH3. What will happen? Water will be lost first. So it will result in the formation of this one. It will be a double bond, then N, then CH3. It's what we call Schiff's base first. Its Schiff's base will be formed. I hope this point is clear. Schiff's base will be obtained. After that, reduction of this imine will take place because this is imine, alkylated imine. Then bond will be broken. Give H to this. That means it will result in the formation of this amine. That means here methyl NHCH3. It is option number D. Option B is the right answer. Option B, it's a secondary amine. On one side it will be CH3 and on another side it will be this group. Okay, option B is the right answer. After this beta, have a look. You are having this one, C triple bond N, and then on treatment with lithium aluminium hydride followed by hydrolysis. First, it will break this bond, add hydrogens to this. So it will result in the formation of, first of all, CH2NH2 primary amine. This primary amine on treatment with NaNO2 HCl, that means on treatment with HNO2, this is aliphatic primary amine, it will form alcohol. That means it will form alcohol. Simply, it will form alcohol followed by, say water as well. Because first it will form a carbocation, then water will be treated, then it will form a benzyl alcohol. So it will be this one. It will be benzene CH2 and OH. That means phenyl CH2OH. After this, it's a very, very simple reaction. Have a look. This is aniline. Have a look. Question says you are having aniline. This aniline is treated with benzoyl chloride. In presence of aqueous NaOH. What has happened? Say for example HCl and NaOH reacts and they will form NaCl and water. Leave that. But what has happened to this aniline? To this aniline, benzoylation has been taken place. Remember, this aniline loses H positive. That means it will act as acid. Whenever any acidic hydrogen containing compound or any compound which acts as acid by losing proton, if benzylation of that compound takes place by using benzoyl chloride in presence of aqueous NaOH, that reaction is known as Schotten-Baumann reaction. So it is simply Schotten-Baumann reaction. So what is Schotten-Baumann reaction? It is benzylation of any acidic hydrogen containing compound in presence of aqueous NaOH. So it is Schotten-Baumann reaction. After that, on hydrolysis of a compound, two compounds are obtained, one of which on treatment with sodium nitrite and hydrochloric acid, gives a product which does not respond to iodoform test. The second one reduces Tollens reagent and Fehling solution. the compound is, listen carefully, listen carefully. On hydrolysis of a compound, suppose this is a compound, this is a compound. Upon hydrolysis, two compounds are obtained. That means one is A, let's suppose another is B. One of which on treatment with sodium nitrite, this on treatment with, let's suppose, NaNO2 and HCl, gives a product which does not respond to iodoform test. So it will result in the formation of a product, let's suppose C, but it does not show iodoform test. That means iodoform is not formed, is not obtained, is not obtained. Okay. But the second one reduces Tolan's reagent. That means it reduces Tolan's reagent as well as Fehling solution. That means this is compound D. It's clear now, as it reduces Fehling's as well as what we call Tolan's reagent, Fehling's solution. If it reduces Fehling's solution, that means it is aliphatic aldehyde. That means it is aliphatic aldehyde. Which one is aliphatic aldehyde? This B is aliphatic aldehyde. Aliphatic aldehyde. Why? Why this is aliphatic aldehyde, beta? Because aliphatic aldehydes, Fehling's test is shown only by aliphatic aldehydes, not by ketones, not by aromatic aldehydes. The compound is, you have to tell me what is this compound. What is this compound? Have a look. Have a look. Have a look. Have a look. If this compound is, first compound, if we talk about, I mean say isocyanide. If it is isocyanide, have a look. CH3, CH2, CH2, NC. Listen carefully. This upon hydrolysis gives CH3, CH2, CH2, NH2. This is what we call compound A, and it results in the formation of this one. That means it is formic acid, because aliphatic aldehyde also shows, or formic acid also shows. Formic acid can also show Tolan's test as well as Fehling's test. That means it is aliphatic aldehyde or Fehling's, or what we call, it is formic acid. So formic acid. So it is clear that it is formic acid. It is not aliphatic aldehyde. Now, so this is our compound B. Now, then question says, the second one reduces. It will reduce Tolan's test. It will reduce, I mean say, Tolan's test or Fehling's test. So leave it. So it is this one. Now, if it is A on treatment with NaNO2, HCl gives C. That means it will result in the formation of, CH3, CH2 positive first. Then it will rearrange. It will undergo 1,2 hydride shift. Once it results in the formation of 1,2 hydride shift, it forms CH3, CH3 with a positive charge. Finally, water will attack on this and it will give us this alcohol. Now have a look. This alcohol is having CH3CHOH. That means iodoform test is not obtained. Iodoform test is not obtained means there will be no rearrangement here. It will be simply like this. It will not form iodoform test. That means it will be simply like this. CH3CH2 CH2OH. So it should be like this. It should be alcohol, and in this alcohol there will be no iodoform test. Okay. If it is cyanide, suppose it is cyanide, it is C triple bond N, then it will be form COH. Only one product will be obtained from this. No, it will not be the, option. CONH, this is amide. Amide is also changed to carboxylic acid. No, it will not be the, product. Amide, C double bond O, NH. No, it will not. It is simply this one. It is simply this one, because it is compound isocyanide which upon hydrolysis gives A and B. That means it gives amine and what we call formic acid. Formic acid shows both these, and amine on treatment, this results in the formation of C, and hydro gives a product which does not respond to iodoform test, because it results in the formation of this NH2 will be lost and OH will be added. That means amine is converted to alcohol. So once it forms an alcohol, this will not form what we call iodoform test. Yes, it is option number C. It is isocyanide. It is isocyanide. I hope this point is clear. It was little bit time consuming. Now, an organic compound among these, when treated with nitrous acid, gave an alcohol and N2. Alcohol, that means it should be an aliphatic amine. It should be an aliphatic amine because it gives alcohol. It gives alcohol on treatment with nitrous acid and evolves N2 gas. It is only primary amine among amines which can evolve nitrogen gas under ice cold conditions. Under normal conditions, only primary aliphatic amine. So it should be amine. Okay, now this A, primary amine, on warming with chloroform and caustic potash, which on reduction gives isopropyl methyl amine. Have a look. It's primary amine. Primary amines are both A and D. It may be A, it may be D. Have a look. If we check which primary amine is this. So first line, that organic compound having this, that means it's amine. When treated with nitrous acid, give alcohol and N2, means it's primary amine. Because whenever alcohol is obtained from amine on treatment with what we call nitrous acid, it is always primary amine. And second thing, when nitrogen is, gas is evolved, when amine is treated with, nitrous acid under normal conditions, it is always primary amine. So it is clear that it is primary amine. Now it's primary amine. This on treatment with chloroform and this one. That means this is carbylamine reaction. Carbylamine reaction, NH2 is converted to NC. NH2 is converted to NC, isocyanide. Which on reduction, CH3, it will remain as such. NC will be converted to NHCH3. This is methyl, this is isopropyl, this is amine. So it gave isopropyl methylamine. Yes, it is this one. It is option A. Now, let's confirm with option D as well. If it is option D, CH3, CH2, NH2, this on treatment with, carbylamine reaction results in the formation of CH3, CH2, NC. But this upon reduction will result in the formation of a secondary amine, CH3, CH2, then NHCH3. It is N-propyl methyl amine, but we know it gives isopropyl methyl amine. So it is option A. Option A is the right answer. After this, acetamide is treated with. Acetamide is this one. Acetamide is treated with the following reagents separately. Which one of these would yield methylamine? Methylamine is this one. So once again, Hoffman bromamide reaction. So it is NaOH-Br2. NaOH-Br2. Which one of the following on reduction with lithium aluminium hydride yields a secondary amine? Now, this is secondary amide. Listen carefully. Secondary amide upon treatment with lithium aluminium hydride gives secondary amine. Because C double bond O of amide is converted to CH2 with the help of lithium aluminium hydride. So it should be secondary amide. Secondary amide. Have a look. This is isocyanide. No. This is acetamide. No. This is methyl. This is what we call, first of all, methyl isocyanide. Methyl isocyanide is this. Methyl isocyanide is this. This is methyl isocyanide. Okay. Then acetamide. Acetamide is this. This will be reduced to CH3, CH2, NH2. That will be a primary amine, but it says secondary amine. After that, methyl cyanide. Methyl cyanide is this. Methyl cyanide is this. Okay. Methyl cyanide. After that, nitrobenzene. We know nitrobenzene. Listen carefully. Nitrobenzene upon lithium aluminium hydride gives azobenzene. It gives azobenzene. Now, this upon lithium aluminium hydride reduction gives primary amine. Okay, this upon reduction by using lithium aluminium hydride gives primary amine. This upon reduction by using lithium aluminium hydride gives secondary amine. So you have to tell me which among these gives secondary amine. This can also, secondary amide can also give secondary amine, but secondary amide is not there. So this is methyl isocyanide. So it is this one which will give secondary amide. This gives primary amine, this gives primary amine, and this gives azobenzene. So obviously it is option number A. After this, it is like this. Reaction is like this. Reaction is like this. 4-methyl aniline on treatment with acetic anhydride. On treatment with acetic anhydride. That means it is simple acetylation reaction first. It is acetylation. H will be replaced by acetyl group. Acetylation reaction first. Acetylation reaction. Now after that, bromination. Bromination. Now this bromine can go to ortho as well as para position now. Sorry, it is CH3 over here. Now this bromine can go to ortho as well as para position, but para is blocked, so bromine will go to ortho position. Bromine will go to ortho position. So it will result in the formation of this one. It will result in the formation of this one. So this is A, this is B. But upon hydrolysis, bond will be broken, H goes to this, OH goes to this. So it will result in the formation of, here it is NH2, to this it is Br, and to para position it is this one. So C is this one, NH2. NH2 BrCH3, that means it is option D. It's option D. After that, dear students, have a look. C triple bond N, then it is OCH3. Then CH3 MgBr, negative part, positive part. Simple nucleophilic addition reaction. Nucleophilic addition reaction takes place. It is C to which CH3 is attached, then double bond N minus MgBr positive. And here it is OCH3. Finally, upon hydrolysis, this bond will be broken and it will result in the formation of C double bond OCH3. C double bond OCH3 and OCH3. C double bond OCH3 and OCH3. It will be option B. It will be option B. Then intermediates formed during reactions of RCONH2 with bromine. This is hypobromamide reaction. Intermediate one is RCONH Br. That means bromamide, N-bromamide. Intermediate second is acyl nitrene, RCON or RNCO. And number third is RN double bond C double bond O. This is formula is RNCO. Both the formulas are basically RNCO. So intermediate is this. So have a look. RCONHBr, RCONHBr, or NHCOBr. No, RCONHBr and RNCO. This is Hoffman bromamide reaction. Then diazonium salt is there. This is diazonium salt which is there. So this is like this. N2Cl minus on treatment with Cu2Br2HBr. This is Sandmeyer reaction during which bromobenzene will be obtained. Sandmeyer reaction. This on treatment with magnesium and dry ether. The function of magnesium, whenever CX bond is there and magnesium is there, magnesium comes in between, I mean say C and Br. So it results in the formation of this one. This is known as Grignard's reagent. This on treatment with water. Water is an acidic hydrogen containing compound. So this is normal acid-base reaction. Normal acid-base reaction takes place and we will get this negative part will say abstract this H, so we will get benzene, and then it is MgBr, and here it is OH. So we will get benzene, we will get benzene. That means option B is the right answer. After that, CH3CONH2Br2KOH. So product will be simply like this. Product will be, which of the following reactions will not give primary amine? Product will CH3NH2. So this is a primary amine because this is Hofmann-Bromamide reaction. And reduction of cyanide by using lithium aluminum hydride will also result in the formation of primary amine. Now NC, reduction of NC gives secondary amine. It gives secondary amine. Reduction of primary amide by using lithium aluminum hydride, it also results in the formation of primary amine. So which among these will not give primary amine? So it is obviously this one, it gives secondary amine. After that, primary aliphatic amines react with, statement 1, react with HNO2 to give unstable diazonium salt. Yes, primary aliphatic amines give unstable diazonium salt, but primary aromatic amines give stable diazonium salt. They are stable because of resonance. Now, statement 1 is correct. Primary aromatic amines react with HNO2 to form diazonium salt. Yes. Which are stable even above? No. This statement second is up to this point correct, but these diazonium salts are unstable above 5 degrees Celsius. That means they are unstable above 270 Kelvin, 278 Kelvin, but it says that it is stable even above 300 Kelvin. No, statement second is incorrect. Statement first is correct and statement second is incorrect. So it's option B. Option B is the right answer. After that, the reagent R, here is the reagent. So reagent R in the sequence of the chemical reaction gives. So have a look, this and this, is this clear? Is this clear? Is this point clear? Is this point clear? It's lagging. Why is it so? Why is it so? Is this lagging? Now is it clear? Is it clear now? Is it clear? Is it clear? Just a moment, just a moment. What has happened? Just a moment. Give me a second, beta. Is it clear now? 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 Now I think it's clear. I think it's clear now. I think it's clear now. Is it clear now? Okay. Okay. So I'm saying that it is basically this N2Cl. Is this visible to everyone or not? Just a moment, just a moment.